안녕하세요. 글로벌 소프트웨어 교육
Afternoon,
컨퍼런스 2일차
everybody.
함께해
This
주신
is the day
시청자
2
여러분.
of 2020 Global Software Education Conference. Nice to meet you. My name
어제
is
이어서
Kim
오늘도
Kyung-mi. I will
글로벌
be your
소프트웨어
MC
교육과 AI
for
산업에
today.
대해서
So
의미 있는
today we are
시간을
going to have a
갖겠습니다.
meaningful
여러분의
time
많은
to talk
관심과 참여를
about the global software
부탁드리겠습니다.
education and AI
함께하고 계신
industry.
방송에
And we
대해서 몇
have
가지 안내 말씀을 드린
participants
후에
for joining
발표드리도록
us
하겠습니다.
online. So let me make
오늘
some
방송은
housekeeping
사이언스 프렌즈
announcement.
채널을
For
통해서
the
전 세계
online
어디서나
broadcasting,
시청을
you can
할 수
join us
있음을
wherever you are
알려드립니다.
through
그리고 이
our
강연의
YouTube
발표와
Science Friends
토론은
channel. And
영문과
for
구문
our
이렇게 통역돼서
presentations and
여러분께
discussions, we
보여드리는데요.
provide it
저희 공식
in
홈페이지
both
접속을 하실
Korean and
때
English. So
한
if
번
you
더 여러분이
access our
선호하는 언어를
website through
선택하셔서
via
접속을
Korean or
해주시면
English, then you can
좋겠습니다.
listen
여러분의
to
많은
the
관심 부탁드립니다.
conference in
지금
either
해외에서 함께하고
language.
계신
So
여러분들을
we
위해서
have participants
잠시
joining
소개를
us from
해드리겠습니다.
abroad. So let me
You can
make the
watch the
announcement
conference
in
anywhere in the
English as well.
world on our YouTube channel, Science Friends. And the sessions will be translated into Korean and English simultaneously in our website. So please stay tuned. 자, 오늘은 컨퍼런스 2일차입니다.
So this is day 2 of the conference, and we will be talking about AI education. So we have the keynote speech and the first and second main sessions. Let us start with the keynote speech. We had such an insightful keynote speech yesterday, and I have even bigger expectation for today's presentation. So the presenter is Leonardo Ortiz Villacorta from Code.org. He will start the
Hi,
presentation.
I'm happy to be with you here at the Global Software Education Conference 2020. My name is Leonardo Ortiz, and I'm the Vice President of International Alliances of Code.org. It's a pleasure to be here participating in this conference. Last year, I had the opportunity to be in Korea and be attending several conferences and meeting computer science teachers from around the country.
시청자 여러분께 몇 가지 양해의 말씀을 좀 부탁드리겠습니다.
Let me ask for your understanding. Actually, we are having this conference through online and offline, but we are having some technical glitch. It will take some time for us to fix it, but if you stay with us for a few seconds or minutes, we will get back to you in a few minutes. Nice to meet you all. We are starting the second day of 2020 Global Software Education Conference. Thank you for being with us. My name is Kim Kyung-mi. We have started this 2020 Global Software Education Conference from yesterday, and we have also quite a lot of meaningful presentations and discussions prepared for today. So let me make some announcements. For the online streaming, you can join us in real time wherever you are through our YouTube channel of Science Friends. And we have simultaneous interpretation for all the presentations and discussions. You can go on to our website and choose the language to join us in your language. And for the participants from overseas, let me make the announcement in English.
In the world on our YouTube channel, Science Friends. And the sessions will be translated into Korean and English simultaneously in our website. So please stay tuned.
So this is day 2 of the conference, and we will be talking about AI education. We have keynote speech and main session 1 and 2 prepared for today. So let us start with the keynote speech. Yesterday, we had a lot of interest from people regarding our keynote speech, and you can also have high expectations for today's keynote speech. We have Vice President Leonardo Cortés Villacurta from Code.org to give the keynote speech.
Hi, I'm happy to be with you here at the Global Software Education Conference 2020. My name is Leonardo Ortiz, and I'm the Vice President of International Alliances of Code.org. And it's a pleasure to be here participating in this conference. Last year, I had the opportunity to be in Korea and be attending several conferences and meeting computer science teachers from around the country. And now in this new scenario of the global pandemic, this is perhaps the best way for us to continue our dialogue. Today, I'm going to be talking about what Code.org is doing, how we see the opportunities and challenges of how to continue advancing computer science education, especially in this new era of AI and the growth of artificial intelligence in society. And then I'm going to invite a colleague of mine, Jake, and we're going to show you some demos of the types of lessons that we have so that students can learn about coding and they can learn about artificial intelligence as well. So we're going to be here talking for the next 40 minutes, and I'm going to share some slides so that we can, walk through these topics that are very important. So, as I mentioned, I'm part of Code.org, and one of the things that we have seen in the past few years is that technology is everywhere. I think everyone knows that already. We have been in a very rapid pace of accelerated change, and the use of digital technologies are present in the workplace, in the way in which we learn, in which we communicate with our loved ones, the way in which we do commerce, engage with government, etc. People call this the fourth industrial revolution, and some countries are more advanced on this journey. South Korea is a great example of a country that has adopted technology in a way that it's present in most aspects of society. Then this year started, and things changed for all of us with the global pandemic. It changed behaviors for those places where digital transformation wasn't a priority. Then we started to see how people rapidly had to adapt to the new scenario. And the global pandemic, of course, brought some changes and impacts in the economy and also in society as a whole. We started seeing social unrest in several places, in several countries, certainly in the United States where I live, but that is not exclusive to the US. And we saw that even countries that before the pandemic were having economic challenges or social unrest, it just exacerbated. So we're living in special times. The impact that the pandemic had in education was very, very hard. You know, we saw it throughout the globe, how schools started closing at some moment. And this image that you see here is a map of the world at the end of March, beginning of April, where over 90% of the students in the world were impacted by school closures. And still, not everyone has been able to go back to school. And there have been places where kids have gone back to school and had to pause that because increased spikes in the pandemic. Right now, at this moment in October, we see that there are still around 30% of schools that are closed around the globe. So that is something for us to continue monitoring and thinking, basically, how do we rethink education? We already saw where we were before the pandemic, how a scenario like this one changes the dynamics in education. But this is a moment for learning. It's a moment to understand how should education systems be prepared to address future scenarios of disruption. And it's also a great moment to reflect not only on what is it that we teach or how we teach, but what is it that we are teaching. Right now, one of the things that we see is that we have opportunities in this world in which there is increased automation. And one of those is how to figure out how to create a workforce or to prepare the future workforce with the skills that they will need to be successful. So I want to talk a little bit about the impact that artificial intelligence and automation and all this technology is having in the workforce. So it is no secret that the workforce is being automated, that robotics, artificial intelligence, and all these new technologies are replacing some jobs that used to be more manual. And now processes and efficiencies are displacing some workers. And there's a need for us to rethink how to support this scenario of the global workforce. McKinsey did a study a few years ago analyzing with the existing technology, the technology that we have right now in the world, what is the potential for automation? And their findings is that right now, if all the companies in the world wanted to automate what is potentially automatable, and they could do 50% of the jobs. 50% of all jobs could be automated, and that would have a huge impact in the economies. That means that a lot of jobs would be displaced, and people would have to be reskilled to be able to come back to the new jobs that are going to exist in a world with more digital related jobs and roles in the workplace. This next slide has just information related to the United States. It may not be relevant for South Korea, but it gives an idea of the trend. This slide is explaining basically how jobs that have less usage of technology pay less, and jobs that are associated with more usage of digital technologies are higher paying jobs. And the other thing that this slide is telling us is that the number of jobs in the marketplace that are now depending more on digital technologies is growing. And that's a trend that will continue in the upcoming decades, of course. The other thing that is important for us to take into consideration is that not all technology jobs are located just in a tech hub. In the case of the US, it's Silicon Valley. But the other thing is not all tech jobs or not all jobs that require usage of technology are in the tech industry. there are many jobs and growing numbers of jobs that are going to be outside of the tech sector. Which brings us to the role of what can we do in the education space to prepare for that scenario in which there's increased automation, increased AI, and more jobs in the marketplace that require more digital skills. We talk a lot about coding. Our organization is called Code.org, but coding is not the end game. For us, the broader concept of computer science is very important because computer science involves coding, but also involves artificial intelligence and computational thinking and networking and robotics, cybersecurity, and there's many other disciplines that are part of computer science, and those are the skills that we actually need to teach in the education system. And this is a great moment for us to think why computer science. For Code.org, computer science is foundational. It is a subject that needs to be taught in schools so that in this increasingly digital world, students can better understand how the world works. In the same way in which we all learned about biology and physics and chemistry, just to understand how engines work and how the body works and learn about ecosystems and nature, etc. In that same way, children from an early age, they need to learn not only how to use technology, but how to create technology. So, as I think one of the main challenges of the education systems now is, as the world evolves very rapidly, is how to teach these skills, but particularly how to teach kids to continue learning throughout their life, especially as technologies change rapidly. So that's a very important skill to acquire, which brings us to AI. When we think about new technologies, we now see that digital technologies have been evolving, and we are arriving into a moment in our history where we're starting to see some inflection points in artificial intelligence. I'm not going to get into the details of how AI is being transformed in the industry, but I want to bring it more to what the education systems should be doing about artificial intelligence. And for us, it is clear it should be included in the curriculum. We actually, as Code.org, have created curriculum for computer science, and we're currently working hard to start incorporating into our lessons in all our curriculum different subjects related to artificial intelligence, because it should be part of the curriculum. The other thing that it's a great opportunity for us in the school system, in the education system, is that we need to teach from a very young age all the students that AI is something that they can use and leverage to find solutions to address some of the most pressing global issues, challenges that we see everywhere. It comes, like, for example, things related with environment and clean waters and addressing poverty and many other things that we see around the globe. AI can be a very powerful tool for finding solutions for some of our most pressing problems. And that is something that you start sharing and teaching from a very young age. Now, AI has its challenges, and there's a very important need to also teach the ethical implications of how people use artificial intelligence. Artificial intelligence, like any other technology, is just a tool, and it's a tool that can be used in a very positive way, but also in a negative way. And teaching ethics and ethics related with artificial intelligence becomes a very critical part of how we need to be incorporating AI in the curriculum. Finally, AI is like the creation of all technology benefits from having diversity in a very inclusive environment amongst the people that are creating and training, especially machine learning, and the people that are teaching artificial intelligence how to arrive to conclusions, how to learn, how to interpret information. The more diverse those creators are, and the more diversity we consider when inputting data sources, the better artificial intelligence is going to identify the diversity of the world, and it's going to provide better solutions, better responses for the information that we're asking AI to help us with. For example, when AI is used in a process to decide if someone needs to get a type of insurance or a loan in a bank, the more diverse data the AI system has been taught with, it's the better responses that system is going to bring, and the more fair for the public that it's serving. So that's why AI needs to have this diverse and inclusive environment in terms of the people that are working on it and the type of data that we're training it with. And also, it needs to have ethical considerations at the center. We're going to talk a little bit more about it in a few minutes. Coming back to this, it's about not only fostering equity in a workforce that it's already out there, but how do we prepare future generations so that the workplace is more equitable? How do we make sure that everyone in the world is learning these new skills? Not only people living in cities, but also students living in rural areas. Also, how do we bring students from underserved backgrounds or from underrepresented backgrounds, whatever that means in different countries. There's always a segment of the population that is not having access. And for us, it's very important to figure out how to bring the majority of the students and all segments of the population to be able to get these skills. So this is our vision. And we're trying to bring opportunities so that every student in every school around the world can learn computer science. We do this in various ways. Driving awareness is one of them. And we've managed to do that in many parts of the world. You see a lot of dots in this global map. Of course, South Korea is included. And we've managed to drive awareness through our Hour of Code campaign, and I'll talk a little bit about it. Actually, now, our Hour of Code campaign is just a campaign that we've done to expose young kids to computer science for the first time in their life. We've created tutorials, they come, they try it. We're trying to make sure that we convey the message that computer science is for everyone, for boys, for girls, for students of every background, for students that may have all sorts of grades. It doesn't matter. Everyone can learn computer science, and you can see it with our results. We've managed to, until actually this year, in the middle of the pandemic, around May or June, we crossed the milestone of 1 billion hours of code that have happened around the world. And these have happened in more than 190 countries and territories. So it's a very important milestone, and it tells you about the excitement for this subject and the appetite around the globe. Yet, the greatest challenge is that still in the majority of schools around the globe, computer science is not being taught. And that is something that we are constantly working to change. We're thinking about how to drive systemic change. How can we do the work with many of our partners around the world to make sure that computer science is taught in all the schools, in all the education systems? That's our aspiration. And in order to achieve that, we do three main things as an organization. We create curriculum and tools, and we have a whole platform that has more than 400 hours of lessons so that children can learn and young people can learn computer science in a fun, engaging way. We have all these resources, some of which are self-guided, so that students from all ages, all the way from preschool or kindergarten, to start learning computer science. And also, we have content for teachers. This is just an image of the different levels of our curriculum for primary education, for secondary education, and everything that we create is paired with teacher-facing materials so that teachers can also learn how to teach computer science. So we do a lot of teacher training along with our partners. The second thing that I want to mention is the type of resources that we build are based on this idea or these principles of, yes, gamification, but also of making the content very engaging and very creative. And you see here just a couple of examples of how our tutorials look and how our lessons look. We start at a very early age just with blocks, which is very easy to follow, and we start evolving so that kids can learn coding in JavaScript in more complex ways, and using devices for physical computer like the micro:bit and others. So that's the type of content that we create. And finally, we work alongside ministries of education and education authorities to make sure that to drive systemic change, that policies are being adopted and that budgets are being appropriated, and that the educational systems are actually starting to incorporate computer science in the curriculum. So that's part of the work that we've been doing. And this is a quick overview of what we do at Code.org and how we see the importance of computer science advancing throughout the world. But I'm going to show you how it looks like, actually, how it looks like for the students. I want you to get a little bit of a taste of how it is to learn, especially to learn artificial intelligence using some of our resources. So for that, I'm going to invite Jake Bell, who works at Code.org as well. He does international partnerships for Asia and the Pacific region, to join me, and we will both walk you through some of these experiences. So to do that, Jake, welcome. I'm going to stop sharing my screen for a minute so that we can. Hi, Jake, do you want to say hello?
Hi, Leo. Thank you so much for that introduction, for including me. I'll just say 안녕하세요. 저는 Code.org에서 일하는 Jake Bell입니다. 10년 전에 제가 한국에서 살았어요. 그래서 아직도 한국어 조금 할 수 있어요. 그런데 이런 소프트웨어 교육에 대한 단어가 잘 모르겠어요. 그래서 앞으로 영어로 말하고요. So yeah, like I said, when it comes to language around computer science and artificial intelligence, I'm still practicing my Korean, and so we'll do the rest of the demo in English, because my guess is that the people listening speak English much better than I speak Korean. But yeah, so like Leo mentioned, we wanted to do a quick demo of some of the tools that we have on the platform that we use to teach students artificial intelligence. And like Leo mentioned, this is an area that we've created kind of a new activity that we launched within the last year. It's called AI for Oceans that we'll talk about. But over time, we're going to be building more and more activities like this that are incorporated throughout our curriculum. So I'll go ahead and share my screen so everyone can see this. All right. So this is the kind of the landing page on our website. It's code.org/oceans that introduces the activity, and has lots of different levels, and it's an hour-long activity that students can go through. But we'll just look at one specific level. So the goal here is that we are training. You can kind of see our representation of AI there on the screen, and we're training it to know the difference between fish and things that are not fish. And the idea is that you can train it so that then moving forward, it could look at something in the ocean and tell you whether it should be there or shouldn't be there. And it's the idea of helping to clean up the oceans, along with the idea Leo had mentioned about AI for good. So Leo, what do you think? Is this a fish or is this not a fish?
I think that is a fish.
All right, so we'll say this one's a fish. I'm going to say this one's not a fish.
This one is totally a fish.
A couple of fish there. This one, I don't think that one's a fish. And then as you go throughout the activity, it gives you some different facts about pollution in our oceans, things like that can keep students engaged. And it gives you kind of instructions that lead you through the activity and teaches you as you do this. So again, I'm going to say, this is not, this is. So now let's go ahead and say, we've trained it. Up here we can see we've done 7 different things that we've told it about. So let's go ahead and, using those 7 things that we've trained AI about, let's let it look at a few different things and see how it does. So I'm going to have it go. It's going to analyze each item and tell us whether it thinks that it's a fish or not a fish. Here we go. So, so that one's right. Okay. Okay, good. It got rid of the banana peel. It thinks that the tire and the light bulb and the banana.
Oh.
All right. So you can speed it up here because the computers can move really fast, but I can just click this button over here and it'll show me the end result. So as we can see, there's a lot of things that aren't fish that made it through. Leo, why do you think that is?
Well, I think AI didn't have enough time to train. I think, didn't learn from a lot of examples. It just learned from 7 examples.
Exactly. And so this goes back to the point that Leo was making earlier, is that we need to make sure that the data that we're using to train AI is representative of the entire population or the entire subset of whatever we're trying to use it for. So in this case, what we can do is we can go back, give me instructions here, walking me through the platform. So yeah, we can go back, and what we can do is we can keep training it, right? So I can say, so now we're up to 9, and so on and so forth. And so the more that I do this, it's gonna give me some more fun facts. Anyway, so the more that I do this and the more data that we provide, the better it can do. And you can, students can use this activity and they can do this and do hundreds of them. I'll just get up here to, all right, 30. Let's try 30 and see. So we tried 7 before, didn't do so great. Let's see how it does with 30. I'll speed this up a little bit. So far, looks like I missed that cup there. But if we go to the end here, all right, so there's much more fish. I only see 3 things there that look like they don't really belong. So this just goes back to that point that it's important for students to understand that when we're training AI models, that it needs to have a lot of data, and that data needs to be representative of the areas that we're dealing in. Anything else you want to add, Leo?
No, I think this is great, and obviously you did what was 30. I guess that if we do 200 examples, then the processing of the data is going to be much better and more accurate. Right?
Exactly. And then up here we can show, so this is showing us everything that it decided was fish. We can also see all the things that were not fish. And so you can see also not only, there's also
like 3
some fish. Yeah. So the more data we give it, the more accurate it can be. But I'm going to jump over here to the end really quick so that we can try something else. So in that example, we were saying, something was a fish or wasn't a fish. But in this example, what we can do is we can just pick a word and we can decide, we can train AI to identify fish that are either angry or happy or sad or scared or things like that. And so let's try this. I'm going to say, let's go with fish that are happy. So what we're going to try to do is that we're going to look at each of these fish and we're going to say, are they happy or not? Now before, we were saying, is it a fish or is it not a fish? That one is pretty, we can all agree what a fish is and what a fish isn't. But now we're dealing with something that's a little bit more subjective, right? What I may decide is a happy fish would be different than maybe what Leo would say is a happy fish. And so this, again, we use this activity to teach students about the ethics around AI, and especially when we're in areas like this, where it can become very subjective around the person who's training the data can train their own bias, right, into the data, and that can lead to challenges. So Leo, I'm gonna let you tell me what you think, and then I'll do it so that it can be to your definition of what a happy fish looks like.
So that's not happy, not happy, not happy. This is tricky. It can be like a creepy happy, but yeah, let's say that it's happy. No, 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 no. Wow, no. Yes, that's a happy fish. No, 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 no happy fish. No, 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 no. Yes. No, no, and yes. You want to see how it's doing?
All right, so we've done 23. So let's go ahead and see. And again, AI is going to analyze the fish, and based on what we've told it, it's going to tell us if it thinks that the fish is happy or not happy. So let's see. I'll go ahead and speed this up. All right, so let's go ahead and jump here to the end so we can see. I think we did pretty well. I would look at that and I would say, I would think most of those fish are pretty happy. Let's see what the not happy fish look like. Yeah. So then one of the other things that you can do with the tool here is that you can see like what specifically it's looking for to decide whether a fish is happy or not. And it looks here like the mouth is the #1 thing that we've kind of trained AI to look for, is that based on its mouth shape, that decides if it's happy or not. And you can actually click on individual fish and it will tell you, right, each of these different things, what it thought was, made this fish look happy versus what it didn't. So
this is great, Jake. It's a great example of how to teach the machine, but also a great example of how you can get it wrong if you're not teaching the machine in the right way, or if I'm biased, right? And if I think that something is happy when it's not, right? I can also teach the incorrect data to the machine.
Yeah. So for example, you can look at all of the fish that are this same kind of bluish color. It thinks that the color is part of why, right? The color is the #1 reason why this fish is happy. When in actuality, the color probably had nothing to do with why you decided it was happy, right, Leo?
No, I was actually looking at the mouth.
Yeah, but so because we happen to choose so many happy fish that had smiling mouths that happened to also be that color, right? The AI model thought that color was an important aspect when actually it wasn't. And so again, this is why we need to give it as much data as possible and need to kind of rule out these cases like this. So yeah, and like I said, this activity has a lot more different levels and things that students can go through. There's different videos that teach students about bias, where they can hear from people that are working in the field of AI. And so highly recommend this as an activity for people to try. And as you can see, we have it translated into Korean as well. So if we have another minute, Leo, I'd love to introduce another tool that's actually not a Kodomo tool.
Let's see it.
So this is a tool that comes from Google. So the Google team created this tool. It's called Teachable Machine, where you can interact with an AI. You can kind of train your own models based on what you want it to do. So this is probably a better activity. The AI for Oceans activity is kind of more fun for, can work with younger students. This is probably something that I would recommend for older students. It is translated into a handful of different languages. Unfortunately, Korean isn't one of them, but hopefully soon their team will have translations for this. So let's go ahead. What we can do is these different classes are basically different kinds of things we want to train AI to recognize. So let's go ahead and, again, before we were training to see if the fish were happy. Let's see if it can tell if I'm happy. So we'll do happy, and then this other one we'll say is sad. So
what about angry? Angry. Can you add one more?
Yeah, we can add one. We'll have to see how good my angry face is. Okay. So then what we do is for each of these, you can either upload your own photos or you can take them with a webcam, and you provide it data, and then we're going to see if it can look at my face and tell me what emotion I'm expressing. So let's start with the happy one. So I'm going to turn on the webcam here so it can see me, and then we'll see if it sees that I'm happy. So I gave it 56 different images, and I tried to move around so it could get lots of different data around that. So now let's go over here to sad. Let's see if I can get it to tell that I'm sad. And this last one we'll do an angry. Let's see if I can do an angry face. I don't think I have a very good angry face, but we'll find out. So once you have all of the data that you've put in, we train the model. And so what it's doing is it's going to go through all of those different images that we gave it. It's going to look at the ones that we labeled as happy, the ones we labeled as sad, and the ones that we labeled as angry. And it's going to come up with a model that can then be used to look at the live version of my face, and it's going to tell me what emotion I'm feeling. So right now it's training the data, meaning that it's taking all this in and
it's learning from it, right?
Exactly. Yeah, and this is in the way that we code other activities. The data that we input is almost like the code in this case. So first what I'll do is point out that at the bottom, you can see these bars where it says happy, sad, and angry. So this shows what confidence the model has that I am expressing that emotion. So apparently in this still shot version, it thinks I'm mostly happy, but a little bit angry. So I'm going to turn this on and we'll try something out. So here, let's see if it sees that I can be happy. And then I can be sad.
Oh, yeah, there it is.
And let's see if I can do angry.
Yeah, I think your angry face is.
Yeah, I don't have a very good. Oh, not angry apparently. Yeah, I don't have a good angry face. And part of it too is we only gave it just a handful of images, so it doesn't have a lot to deal with. Now, Leo, what do you think would happen if we tried this model on you?
Well, I think that if you put my face there, probably the accuracy is going to be even less, because if it only trained with your face and you put my face, then it's not going to be very accurate.
Yeah, exactly. So, because it's only had data about me, if it tried to guess the emotions of someone else, it would have no idea how to do that. And so, again, this is an area where we try to make sure that students understand that if the model is only given data or images about one race or one gender or one nationality or ethnicity or anything like that, then when it tries to be applied in other areas, it can cause a lot of mistakes. And there's some areas where that could just be, a mishap and it's not that big of a deal. But when you think about this being used in medicine, for example, and being used to diagnose diseases, it's critical that we understand that this has to be done in a certain way and that we're teaching that to students today.
Thank you very much, Jake, for those demos. I think this is a great way to explain how we try to teach AI and the resources, some examples of resources that teachers can use to teach AI to their students. Now, to finalize our presentation, I just want to mention that resources like AI for Oceans, you can see that in our code.org platform. We currently have more than 55 million students with accounts. We have many more students that use our platform, but we don't require them to use accounts because we want to lower the barrier of entry. So there are several more millions that come to our platform and just go and use our content, but there are 55 that are using it with an account that tracks their progress. Around half of them are women, young women. That's for us is very important because there's a gender gap, and we need to make sure that we're also bringing equally number of female students to learn the skills. And we've seen obviously a lot of progress around the world. I showed you a map before. This is just a series of photographs that depict some leaders around the globe that have done an hour of code, that are now more interested in advancing computer science. There are around 50 countries, a little bit more than 50 countries in the world that have already either incorporated computer science in the curriculum or announced the intention to do so and starting to do the first steps. South Korea is definitely there. You're doing a great job in incorporating the skills in your education system. And I know that you would be the first ones to also recognize that there's more work to be done. This is just a constant journey, and we're happy to be also putting our resources at your disposal. We're currently finalizing the translation of our computer science fundamentals curriculum, which is the primary curriculum or curriculum for primary education into Korean, so that more students in South Korea can use our resources in the same way as they have been using our tutorials from the Hour of Code. So this is a movement. There are many organizations in the world like Code.org, other nonprofits, governments, ministries of education, companies, and many others, enthusiasts that are trying to advance this subject. And this is, as I mentioned, just the work of many, many, many people. And we invite you to join us, to join the movement, try our tutorials, try our lessons, teach that to your students, if you have students, to your children, if you have kids. And we will be happy to continue working with South Korea so that it continues being at the forefront of computer science education, and now incorporating artificial intelligence in the curriculum as well. Thank you very much on behalf of Code.org. Jake, any final words here?
No, thank you so much for inviting us and for letting us present about what we've been doing with computer science and AI.
Well, thank you very much, and until next time, hope to be with you again in another opportunity. Goodbye.
Thank you for the keynote speech. I hope we can actually meet him in person next year, so we could hear a lot of great insights about AI education, and he had very clear insights into the Korean AI education. So we will go into session 1 of day 2. It's about AI education platform. To moderate the session, we have our moderator. He is the president of the Software Centered Universities Consortium. So he will be moderating the session. This is Seo Jung-yeon, professor of Sogang University. Good afternoon. I am Seo Jung-yeon from Sogang University. So as you all know, AI is becoming very important in this time. Future national competitiveness would lie in the AI competency of the nation. That is what many people say. So nurturing AI talent is like a national task, but individuals also need to focus on learning AI for their own future. But if you look at what is happening in the education field, we don't have enough AI experts to teach students about AI. This is also the same situation for most of the advanced countries. So in this situation, we are in a dire need of developing AI education platform to enhance the quality of AI talents for the future. Online education is being the key word in our post-coronavirus era. So I think this is quite timely to talk about this issue. And we have diverse speakers and moderators to talk about this AI education platform. So we will now start session 1, and it will be moderated by Professor Seo Jung-yeon. So to start the session, we have our first presenter from Microsoft Korea, Director Shim Jae-kyung. Director Shim Jae-kyung, Mary Shim, will talk about global status of AI education platform. So please come forward. Good afternoon. I am Mary Shim from the education sector of Microsoft Korea. Although we are meeting you online, it is such a great honor to talk about Microsoft's educational tools and solutions. And I think it's quite timely and appropriate to talk about this issue in this time. So rather than just talking about education for specifically education, AI only, we talk about this as the future skills, and we are focusing on certain skills as the key skills needed for the future talent. So let's first watch a video clip together.
We are all teachers.
And we're all learners.
We each learn in our own way.
We are designing an acid rain shield for Taj Mahal.
We are working on the science and archaeology behind Pompeii.
We are working on how we can save water, and it was really cool.
We are surgeons and climate scientists.
We are architects and artists.
We are anything and everything we want to be.
I want to be an engineer and a poet.
I want to be a lawyer to help other people see reality.
We all have our own challenges.
Math is sometimes hard for me. I'm really bad at writing.
Programs are challenging for me,
But we find ways to make them opportunities. So we can see and understand. And come together to solve problems.
Then it would come down this way, go to the filter. Then it would come into the rain catcher.
In school
And in the world.
I want to help people by breaking stereotypes, showing people that we all stand together.
I would probably try and help people who aren't really confident in themselves.
I want to see the world turn into a better place for everyone.
We're not waiting for tomorrow.
Because we're creating a future today.
So today's conference is also about our children, how we can have them have their future and accomplish their dreams. So philosophy of Microsoft was embodied in this video, and that's why I wanted to share it with you. So you know Microsoft as an IT company, but our education philosophy is to empower the students of today to create the world of tomorrow. So we want to be their supporters. So we create education solutions and programs. And you can see the photo of our CEO. So as I already said, at Microsoft, we have, of course, our technologies, but we understand that with the time changing, we focus on what are the new technologies needed and what are needed for different phases. And based on those definitions, we share them with students and academics and institutes. You can see here that for students, for example, this is in English version. You can see that for AI education and software education, in Microsoft's view, it is to encourage students to have interest. Education is not easy, but if students have interest, if they are intrigued, then they can go on to the next step. So these are what are needed for each steps. Also, there are technical factors, but what is also very important is like computational thinking and computer literacy across all the primary, secondary, and higher education that should be integrated. If not, well, the effect would be even worse than without having it. So those critical thinking and digital literacy should be linked, starting from primary to the higher education. So it's not just about experiencing, but they would start with interest, just simple, pure interest. But in the end, they will come up with a concrete output. So we have a seamless process prepared for students. So this is one of my favorite slides. At each step from like primary, secondary, and higher education, those are things needed and competencies required and solutions needed to nurture those competencies. Just a side note, well, one of the biggest strengths of Microsoft is that, well, it's quite hard as a presenter to talk about this, but there are so many Microsoft solutions out there. AI education of Microsoft is integrated, and these resources are provided to learners. In many parts, they are given for free to students and teachers and institutions. If they want, whenever they want, they can access it, and mostly they are free of charge. We are a B2B company, and this is about production and creation, but it's not just about creation, but we believe that productivity should be also secure. So we have Imagine Academy, where all our science, like computer science, software science, and AI data, those courses can be learned through this Imagine Academy. And recently, across the world, we have been implementing retraining, re-education for the aged people or people without jobs. We have done this survey on what are needed, and based on our survey, we have made some announcements, and one of that was this using LinkedIn or using Microsoft to learn, which is like with the fourth industrial revolution, the key competencies or skills can be learned through those sites. We are operating those sites, and if you go on to those websites, you can see that children or teachers can find and learn what they want to learn. And you think that Microsoft is like providing AI or cloud solutions for developers. So in that regard, we have education program on GitHub, which is like the sacred land of developers. And these programs are not just about experiencing and learning on your own, but it will lead to internationally acknowledged certification. So final output would be acquisition of those certifications. So I have tried to cover so many things in the presentation, but you can see here a program called MS Learn. So it is like about AI, basics of data, and cloud. So currently in software and AI, there are some competencies required. So you can see all of them here. And at Microsoft as a company, we understand how when some people learn AI, how we can specify those skills into the requirements of different industries. So we have curriculum for that. So it's called AI Business School. Either you can be a student or a teacher. You can learn the course and come up with output and apply it to different industries like agriculture or retail, any industries that you are in. So your output can be applied, or for example, you can look into different actual applications in different fields. So you can see various AI-related courses. Recently, we have understood the importance of the workplace practice. Also, of course, there are some textbooks and lectures, but it's important to experience those learnings and to apply them. So there are those websites to do that. Well, my 15-minute time is too short to cover all the solutions that we have, but I will be just briefly introducing them to you. So we have Azure in Education. It's a cloud platform, an AI platform as well. So students and teachers and educators and institutions can go in there and find learning for free. So you can just take it as a reference. One of our strengths is this link with GitHub. So even in GitHub, students or teachers can learn the related courses there. I tried to cover so many things here, so I will be skipping some slides, starting from students to developers and actual application of the solutions. We cover everything, and starting from last year, maybe even back years ago, regarding AI textbook, Ministry of Education and all the related agencies are reviewing how we can create the proper AI textbook. And in that regard, we have completed a Korean version of our AI textbook. So this one is used in the US and India. It covers for 3 grades. So you can see student's handbook and teacher's handbook for 3 student grades. So it covers AI basics and fundamentals of data, and based on that you can do the actual practice. So it is a comprehensive course. So it doesn't fit with the regular curriculum of Korea's educational system, but there should be some adjustment made in the future, but I just wanted to mention it. So actually, I added this slide after I arrived here. Just a few days ago, we have announced this program called Over the Moon with the partnership with Netflix. This is like a AI course or AI project. So this Over the Moon, it's like exploitation by NASA going over to the moon. So I just went to this solution and looked through. So it's very interesting, and it's PBL-based learning. So students will find it very interesting and easy to approach. And at each step, there are some special instruments making students keep on learning. And for this program called Over the Moon, there are some tasks to be completed for students to go on to the next step. So all the courses and programs and the steps are made in Korean, so you can enjoy the learning in very easy way. So related to AI, there are so many things that we have at Microsoft, but unlike other companies, what we have is this Imagine Cup, an international challenge cup. I believe that students and children of Korea are quite outstanding. And these children, if they learn about AI and software solidly and properly, if they join these challenges, I believe that they can showcase their abilities to the world, but related to AI, they didn't have those chances so far. And since last year, we have introduced this AI challenge. For example, for Imagine Cup, it has a long history. And since last year, we added this Imagine Cup Junior. So it's called AI for Good. For this challenge, I believe that Korean children can showcase their great strengths to the world. Also, we have, as I said, internationally acknowledged credentials to be provided if you accomplish the course. It is not just limited to Korea, but it's a global certification. So even if you acquire in Korea, it can be utilized across the world wherever they go. So you can see that we have the connection with GitHub. So this is the end of my slide. Although I was just given 15 minutes, actually it was quite a short time to cover how we provide AI education at Microsoft, because we are not just providing AI education, but provide a comprehensive education for this technology starting from elementary school years, focusing on the required competencies. So it's not just experience, but getting the actual hands-on knowledge and also getting credentials and getting jobs. So it is like a comprehensive program that we provide. So thank you very much for listening to my presentation. If you have any questions, please don't hesitate to contact us. Thank you.
Thank you very much for your presentation. Thank you. I'd like to invite the next speaker. The next speaker is here with us online from Germany. Professor Stefan Sigurer from Berlin University. He will talk about unplugged AI. Are we connected to Professor
Hi all.
Stefan?
Thanks for having me for this talk here. I'd love to come to Korea, but unfortunately I'm now speaking from Germany to you. And my talk's about unplugging artificial intelligence, or the importance of the underlying ideas. And this is a German perspective that I want to share with you today. So we all know those examples from AI. AI comes in a lot of different shapes, whether it's in games or with services like Netflix and Amazon, with Alexa, with Siri, with spooky robots, or with self-driving cars. We interact with AI, but we're also confronted with many associated questions. Who is responsible if the AI fails? How should the AI decide a certain dilemma to crash into the group of school children or the pregnant woman? And those different facets already outline the goal of AI education in Germany. So AI education in Germany wants to enable people to participate in an increasingly digital world by using it consciously and to see how it affects them personally. And furthermore, students should get involved in shaping this world. A foundational knowledge about AI enables people to not only use applications of artificial intelligence, but also to design and create their own solutions. And with an increasingly important debate about the ethical implications of AI, the goal is also to make informed decisions about AI in society. This aligns with the three perspectives we often refer to with education in today's digital world, with all the modern technology. So we need to use, or we need to take an application-oriented perspective where we ask questions as to whether or how we can apply or use stuff like artificial intelligence. Then we have a technological perspective where we ask questions, how does this stuff work? And how can I create my own solutions? And there is a societal perspective where we ask questions as to whether or how technology affects our society. So those are bold goals, don't get me wrong, but we want to educate people for the next 50 years, not only in the next 2 years. So how can we achieve this with AI? And therefore, I want to take you on a thought experiment, because there is no doubt whether or not we should teach AI to educate people for the next 50 years. But the more interesting question is what to teach. Which topics are relevant for students to learn, regardless of if they will become computer scientists or not. And to help you experience what I mean, I want to invite you to do this simple thought experiment with me. Please try to remember the alphabet that's provided on this slide within the next 20 seconds. Okay, time's up. Can you translate those 4 symbols into numbers? Well, it was 1337. Does it match your solution? You may find this task extremely difficult. And you might ask, why on earth you would need to learn that? And that's the kind of question that's the right one. Actually, this coding is inspired by telephone dial keys. So the 1 is encoded as a border to the bottom and to the right. The 5 is a complete square, and the 8 is like borders everywhere except the bottom. So you get the idea. While remembering the whole alphabet within 20 seconds or 30 seconds is very hard and difficult and rather pointless, it's actually rather easy if one understands the dial key idea, the underlying principle of the encoding. If I made you learn the underlying principle instead of the full encoding table, you would have been able to decode 1337 probably much easier and much faster. In fact, you might recall this encoding for the rest of your life. And by the way, this thought experiment is borrowed from the great work of Klaus Brabant and Jacob Anderson with Teaching, and Understanding, which is a 19-minute award-winning short film about teaching at university and higher level education that you can find on YouTube. But what can we learn from this experiment for this talk or for AI education? We can learn that in teaching we have to focus on the underlying idea as well and need to figure out what that is for each topic, and not just on certain application of frameworks or a topic. Applying this to AI education means that we should favor the understanding of underlying principles, such as how machines learn, rather than just the usage and application of a couple of tools or frameworks. In addition, only a look at those underlying principles will enable students to discuss the topic of AI in a differentiated and conscious manner. For the rest of my talk, I want to focus mainly on machine learning instead of AI in general. So what are the underlying ideas of machine learning? So in this case, we don't need to think of the specific algorithms, but more on what those algorithms have in common. So for machine learning, this is probably there is supervised learning, where visualized by this robot, we have a lot of labeled data in the form of bricks with labels like A, B, C, or D attached. And we look for patterns to match input and label, which then can be used to label new data, such as new geometric bricks. Then there is unsupervised learning. In the case of unsupervised learning, only unlabeled data is available as input. The algorithm identifies similarities and patterns in this data, and the resulting model can be used, for example, to group the data or to find outliers. And there is reinforcement learning. Reinforcement learning consists of 4 steps. An agent is capturing a state of the environment, it's choosing an action, such as in this case watering seedlings or taking the spade and planting seeds, and depending on the following state of the environment receives a reward or a punishment, and This way, the agent is able to optimize its strategy. So based on the reward he receives for a certain action in a certain state, the robot learns that watering the seedlings seems like a better action for the state seedlings are already planted than using the spade to pull out those already planted seedlings and plant new ones. The reason why I can show you this in a Korean translation, by the way, is thanks to some awesome folks that are noted on this slide. And so now that we know how those underlying ideas could look, how can we teach them? And therefore I want to show you two collections that were created, collected and shared with the teaching community in Germany. The first approach to AI education that I like to show to teachers is the Unplugged way. So to focus on the underlying principle and to give teachers who might or might not be very much into computer science, we use a lot of those Unplugged activities that we collected also in a brochure that has been translated into Korean as well, which is a really great thing. And Unplugged activities, they all share some common characteristics. So obviously there is no direct use of computers involved. Often a game or a story or a challenge is somewhat involved. And to allow for kinesthetic engagement, one might use physical objects as well. And they're overall all about fostering interaction and collaboration, and last but not least, they are mostly really simple to carry out. And this is an important part. A lot of teachers tell us that they are unsure how to start, how to get into AI education, and that they are afraid of using all those wonderful tools, programming tools that are all around us. And that's why we tend to always show them Unplugged activities first, as it sort of breaks the ice and starts to welcome them to the community. And for exploring supervised learning, we love to use a game for the classification mechanisms, where we have a group of monkeys and we know which monkeys bite, and soon new animals will arrive at our zoo or join our group, and we'll have to think about how to distinguish biting from non-biting monkeys, so when we feed them we don't get bitten. And students then investigate how these examples belong to the categories, note criteria, and, for example, develop a decision tree. And the resulting models are then tested with new examples and the best models selected. We can also learn about unsupervised learning this way. In this Unplugged game, we want to give students the chance to find gold in the Wild West, and they'll get unlabeled data in the form of gold findings. They need to find similarities, in particular regarding their coordinates, and use them to identify clusters and outliers. And we also can do reinforcement learning this way, using this great hexapon game by Martin Gardner that we adapted to fit inside this collection as well. The second approach I want to show you is using the block-based programming language Snap. But it differs from approaches like Cognates or ML for Kids that use Scratch, which are great tools. But instead of only applying libraries or making API calls, which do the magic for us, users in this example should be able to also look inside the black box and even make adaptations to the ML algorithms based on their needs, at least to some extent. And to this end, languages like JavaScript are avoided completely. So while many other systems need extra services on which models are trained or use API calls in the background, we tend to contradict the perception that it's just a learning language and we need to use those external services. So we make everything work inside Snap, so inside this framework. And so all the magic is happening inside their own program. They can look behind the scenes, they can watch, adapt, or experiment with all the code that's in there. And according to the constructionist learning theory, users should be also to create their own personally meaningful project and use the system to enrich them. So this poses a contrast to some of those learning projects where often artificial problems and examples are chosen because They are suitable for visualizing and for doing the real algorithms. So we still try to allow for really cool projects. For example, like in this image where we implemented reinforcement learning with a simple banana hunt game. But it also works for other games and for other situations. With block-based environments that allow users to store and save all variables locally, those models can become even more concrete, which supports this constructionist idea of artifacts as like tangible artifacts, tangible results. This allows several new and interesting ways to integrate those ideas into the classroom. For example, as a competition for students to compare the models and learn from each other or discuss them. So with this framework, we call it SNAPE, we propose a way to address ML in the classroom with SNAP, with the clear goal of breaking the black box open and focus on the underlying ideas. What can this approach now show us? Well, making the actual learning process visible and adaptable helps us focus on the underlying ideas, because we're not bounded by the big machine computing power that we need, but just by the idea that's behind that. And that's enabling a deep understanding of machine learning. And by using approaches to machine learning other than classification and image recognition, we again show the diversity of possible ways machines can learn, contributing to our understanding of underlying ideas. So what both of these approaches had in common was that they focus on the core ideas, that they allow to explore what's really behind learning or machine learning, otherwise often being lost in a lot of other things we need to capture or conquer. And fostering underlying ideas helps not only students to keep focused, but also we as teachers profit from them, because we know what of the stuff really matters. And unplugged activities, they not only offer an interactive way to explore those underlying principles, they are also a really good way to attract teachers feeling uncomfortable with teaching unknown knowledge areas like AI. And yeah, well, still we need to provide ways that are accessible but allow to dig deeper. And that's why we have this, or I showed you this AI and SNAP stuff as well. So still, we should never forget to focus or to highlight what these students are learning about, what the underlying ideas are. And finally, what or how can we use this to create a platform for AI education? I think it's not only that we design those materials, but how we distributed it. So they might be downloadable from the website, but the real reason why those materials are actually used, adapted, and shared across German states or institutions is that we really distributed a lot of physical print copies, and that we build a community of practice around it, where teachers and educators share variations of the materials and use it in their own workshops and trainings. And a lot of these ideas we actually have combined into MOOC, and it will be available soon in German and English via OpenSAP. Thank you so much for your attention. Thank you for being here, and thank you for having me, attention like in BERT models. And I think together we look into a bright AI-educated future, and I would love to hear what you are thinking. Thank you.
Thank you, Mr. Stefan, for your great presentation about very interesting topic. We now have the next presenter from Amazon's AWS. We have the Chief Evangelist, Mr. Yoon Seok Chan. He'll be talking about global status of AI education platform and cloud AI education use cases.
반갑습니다. 저는 AWS에서
Nice to meet you. I am the tech evangelist at AWS. So for those of you in the educational field, I will be talking about how we are utilizing AI for the education. So AWS is like a lab, Amazon Web Service. So it is like developers, whenever they want, they can use this computing service to create a perfect data. So when we first created this AWS for the first time, we thought that the physical computing resources like CPU, memory, and hard disk should be split into services. So this cloud computing itself, like electricity or tap water, we should be able to use it whenever we want, in the amount we want. In educational sector, we are utilizing cloud computing a lot. There are some education startups using it, and for online education, to approach many students, well, we don't want to purchase the physical resources for each of those trainings. So we use cloud computing for those purposes. And also at universities for the computer labs, we are using the cloud computing. So there are more than 1,000 educational institutions across the world, including those in Korea. I said that we started with a few number of services. So now it's not just about CPU or memory, but also AI, media, mobile. All these devices have more than 175 services provided through cloud. So when there are new services or new ideas, actually we can find them all on the cloud. AI has had a lot of changes with the online. So this is Bono Bornes, our CTO, who said that new changes are made with the cloud. Recently, we had the development of the deep learning. Actually, deep learning is an old technology, but with the computing power and data size made possible with the cloud, we had the leap of the deep learning. Many people, actually, when they try to create this kind of deep learning with their own resources, actually, it takes up a lot of computing power. So you can see that this is the CPU power made by NVIDIA, but actually it has about 100 of the CPU's power. But on the cloud, we can use it for $5 per hour. So if we are to use the computing power of 2,000 CPUs, actually it will be just $100 per hour. But that is, of course, not minimal. So what we are trying to do is to provide those resources at a low price. So even if the listed price is $5, if we are using the remaining resources, then the purchasing price can be discounted by 70%. So for the same computing power, you can use it for $30 per hour. So these are some freedoms or advantages made possible with the cloud, and there are many innovations made in the educational sector with the cloud. So I want to first talk about how some startups are doing with cloud in this educational sector. In Korea, we usually think of like private sector education, like after school private tutoring. They're using these programs. In case of Acre, well, in the US, you have to write a lot of essays. So you send your essay to Acre, and they will be correcting your writing with this new machine learning model. So it's like a learning tool that students can utilize. And in case of Duolingo, I think you know about this already. It's like a customized learning service for diverse languages. So if you're trying to learn a foreign language, if just with a few clicks, you can tell the solution what your traits or characteristics are. And based on those information, this service provides a customized service for the foreign language learning. Next one is the Mathpresso. Actually, what they did was to connect students to the private tutors to solve math problems. But with this new deep learning service, it allows the solution to solve the math problems that students are finding hard to solve on their own. So I have covered all the solutions in the sector of foreign language and also writing and math. So you can see that it is really helping reduce the loads on the teachers with the current COVID pandemic. Well, it's hard to get the education at school. We had the lockdowns and lockups at schools, and with a lot of efforts from teachers, we have found some solution, but the situation is still persisting. In particular, there are some courses where online education is not possible, like when there are some tools or instruments needed, like CAD/CAM. For specific IT training, we need additional supports. So in case of teaching students with high-performing cloud service like CAD/CAM or AI that is supported through that. So in case of a school district in New York, they utilize this and supported that to their students so that actual practices of those technologies can be done at home. Usually, students don't have the laptops with such a strong computing power, but they get the support in that regard. And as students are staying at home, they can get the access from the educational institutes. So it's not the central institutes, but a local educational agencies that have the direct connection to students. When students have difficulties in resolving learning-related issues when they are getting the online training, they can call this call centers. So in average, maybe more than 1,000 calls are given to those call centers. There should be consultants working for those call centers, but we have put this on the cloud. It's possible to create a call center through just a few clicks on this solution, and there will be like an AI chatbot to respond to students' questions. So just within a few weeks, that school district created the call center and responded to their students. And for the online learning, it's very critical to make students keep interested in their learning. So there are many training that we provide to teachers, but also what is needed is something that is like animated, moving factors or points inside the learning. So there is like a machine learning inside, so that students can find it more intriguing. And in AWS, we offer various services, and one of that is RoboMaker. So when students go into the console, they can find the model that they want. For example, this is like a floor cleaning robot simulated. So students can try this and find ways to make it easier and more effective. So they will be modifying the algorithm to make this robot more effective. And actually, some companies are using this today. I wanted to tell you how easy it is to illustrate this. We have this cloud console. If you go on to the console, you can test many things. For example, this is called pervasion. So in the photo, there are many objects. So you can have things recognized. What are the objects on the photo? So if you upload your photo, everything will be processed instantly. If you do the coding well, then it will be connected to APL so that you can make modifications to the photo instantly. So everything is done in the cloud. Also for text, if you do the text input, it can convert it to speech. In the past, we could just instantly get the text converted to speech, but you need to make some modifications for this to customize to your own needs. So how can we make AI learning more interesting? There can be these tools provided by cloud companies. To have the visual recognition, we can have Deep Lens, and for the sound recognition, we have the Deep Composer, and for the reinforcement learning, we can have this kind of Deep Racer, which is like an autonomous car that students can try to learn about this. To see how it's applied in Korea, when students go into the console, it's like a reinforcement learning. So we can get students receive rewards if they do the proper modification of the algorithms. So students can try this kind of racing, not just on offline, but also online. So students can try this racing and create the model that they want. At AWS, we have the Deep Racer League. It's an offline league we do every year. So students come with their model that they have created and put it on this track and see if it's going properly autonomously. In Hong Kong, there is like a vocational school, and their team had won in this race. So it shows that even amateur students can win against professionals. At AWS, we have a lot of cloud-based educational programs. In particular, we have AWS Educate program. It's targeting university students around the world to learn about cloud and AI. It's like an educational course. So it can be costly, but actually students can learn free of charge. And recent trend is that it's not just limited to universities, but actually teachers of elementary school, middle school, and high schools are applying for this. So we are supporting that to teachers of those primary and secondary schools. About 100 schools in Korea are getting this program, and in particular, like science specializing schools and other some specific schools are receiving this program in Korea. Sometimes we go to the site to provide the program. Sometimes we do the educational startup support programs as well. Lastly, I want to cite the words of the founder of Amazon, Jeff Bezos. Children have a lot of dreams when they are young, but it's hard to accomplish them during the course of the school. But many companies are interested in education. Microsoft, us, same. So from the view of the industry, I think that we can do many things. Newton, well, when he was talking about the development of the science, he said that his discovery is based on the inventions and discoveries of what the preceding scientists have found. So if we understand that and try to cooperate together, I think that we can create good educational environment in Korea. Thank you. Thank you, Mr. Yoon Seok-cheon, Chief Evangelist, for your presentation.
So we have listened to the 3 presentations. Thank you very much for your presentation. From now on, I'd like to invite 2 panelists. The first panelist is from Chongshin University College of Education, Professor Soo-han Kim. Professor Soo-han Kim is now online. Nice to meet you, Professor Kim. Nice to meet you too. I am teaching students at the College of Education at Chongshin University. I am honored to participate in this conference. And the second panelist is from Daegu Hwanam Elementary School, and also he is serving as an important member of the Office of Education, Mr. Chung Seo-lee. So we have 2 panelists. I'd like to ask each of the panelists to make comments for about 5 minutes respectively. Could you make comments about AI educational platform? Could you share with us your idea? First of all, Professor Kim. Professor Kim, do you hear us? Yes. Could you please spend about 5 minutes for sharing your idea on AI education platform? So for about 5 minutes, I'd like to share my idea.
저는 지금 그 서정연 교수님께서 소개를 해주신 것처럼
As Professor Saw mentioned,
특히 이제 K-12 학생들을 위한
especially
초중고 교육, 인공지능 교육에 관련된 여러 가지
there have been many efforts. I have been putting efforts for creating software educational platforms for K-12 students, and I also conducted the fundamental basic study on AI education. And Professor Stephen Seeger and the chief evangelist from AWS and the director from Microsoft Korea, thank you very much all for your presentation. It was very impressive. So I'd like to explain about what we can do to provide proper AI education to Korean students. In Korea, we have computer science-based education, which is named software education, which was applied to the elementary school and middle schools recently. For middle school, students receive over 34 hours of software education, and elementary school students, they also mandatorily receive certain hours of software education. And it will not be easy for us to help students grow their computational thinking ability only through the mandatory software education courses. As Professor Stephen Singer mentioned, we need to come up with more sophisticated education curriculum and platform so that someday our students will be able to use and produce AI solutions. The Korean government's plan for AI education includes the inclusion of AI in the official curriculum of elementary school and middle school students. But one problem is that still we are lack of hours of classes, and we need to foster the competent teachers who are able to actually teach students such AI subjects. And as you know, educational systems and institutions do not change in just over a night. We have to foster the competent teachers and improve our curriculums, and we need to go through a lot of processes, and it'll take a long time. So I'd like to ask all of you. I actually want to make a request for all of you. As our speakers mentioned, if you look at the current society, if the educational divide happens, then that will have influence on the career path and the future of our students. In terms of software and AI education, we need to close the education divide. So we need to secure the proper hours of classes when we officially adopt the AI curriculum for elementary school and middle school students. As for software and AI education, basically we need computing and coding tools. So we need an AI education platform, including computation and coding tools. As Professor Stephen said, the educational AI platform must be different from industrial AI platform. We need to enhance the engagement from children, and we need to help teachers teach students in a fun and entertaining way. And also we need to provide teachers with such resources and materials. So I think we need to have more improved, upgraded AI educational platform in Korea. As you know, the logo from Simon Pepper, as well as Snap and Scratch mentioned by Professor Stephen, we have some tools developed which are at entry level. So in the case of AI educational platform, they should provide the services and functions that are tailored to the learning needs and tailored to the purpose of education. And we should make sure that the AI education does not end as one-off event. For ensuring sustainable education, we need to make efforts. We need to have cooperation between the public and private sector. And as Professor Steven mentioned, and we need to help teachers receive teachers trainings, and we need to create and enrich the community of teachers who teach students AI. Through the conference today, we are talking about the AI educational platforms, and I hope we could have further discussions and get useful ideas for our education.
Thank you, Professor, for your comment. Now we have Ms. Lee Jung-seo. So can you make a general comment? Nice to meet you. I am in the educational field, teaching students about AI and software. With the AI education introduced at schools, well, I get a lot of questions. What is education on AI? So when I actually do it with students, actually they say it's so fun. So when they first learned about software, they found it very interesting, but I told them that if you learn about AI, it will be even more fun. So AI, well, it's seen with diverse views. For example, people think that just experiencing AI is learning AI as well, and using AI to teach students, like measuring their performance or helping them learn things. Well, some people say that it is also AI education. And some people say that if you learn about principles of AI, that is the AI education. And if you look into AI education platforms, there are so many different kinds. For example, there are AI programming platforms and AI principles learning platforms, and etc. But I find that the platforms that teach the principles, the basics of AI is not sufficient compared to the ones that we can practice AI. That is what I wanted to mention. And one thing to ask is, there are great platforms, overseas platforms, but they are not localized to be converted to Korean or to meet the educational system of Korea. But I think there's something that we need to work on to introduce them to the educational field of Korea. Thank you for your comment.
Here we have the distinguished guests from Microsoft and Amazon AWS. Thank you very much for introducing very good systems to us. As Mr. Lee, the teacher, asked, in Korea, elementary school and middle school curriculums are not really properly defined and established. And AWS and Microsoft have good educational curriculums. Can we combine those curriculums with the regular school curriculums? That's the question many people ask. What do you think of this?
Well, first of all, as you said, basically, that course came from the US. So compared to the educational system of Korea, it is not a perfect match. But we are just providing these tools and support technologies, but just making them to fit into the Korean education system, that is something that we need to work together with teachers of Korea. And I understand that we teach these courses not just as a regular curriculum, but as an after-school curriculum. And for middle schools and high schools, we have done some pilot programs for the science specializing schools or Meister schools. But for now, I think that collaboration with teachers is very critical for us to adjust it to meet the Korean situation. I have mentioned some examples of our courses, and there are some overseas education curriculum provided from K-12, but they are just starting, in particular for the elementary school students. So at Amazon, we are also testing those possibilities. We are doing things, but they are not perfect yet. And as she said, we need a collaboration with teachers, and most of the courses are provided online, especially with the pandemic. It is not easy to provide the courses offline. So as the courses are provided online, we still need to test them a lot, and actually we need a lot of more test beds to prove whether they can meet the requirements of Korean students and teachers. So of course, introducing overseas curriculum is important, but also devising the ones that meet the Korean situation is very important. And as she said, a collaboration with the educational field is very critical. Thank you.
And Professor Stephen from Germany. Professor Stephen, do you hear us clear and loud?
Yep, I hear you. I can hear you. Hi.
Can
you hear me as well?
잘 들리시나요? Yes, we hear you clear. We have some questions about the situation in Germany.
Go ahead.
So can you explain about the computer science curriculum for K-12 students in Germany, and how are you teaching K-12 students AI? That's the first question. And second question is, you introduced SNAP, the educational platform. Is the SNAP and other AI educational platforms are well combined and blended with your regular educational curriculum at schools?
Okay, I'll start off with how the education or computer science education works in Germany. So Germany consists of 16 different states, and education is different for every state. So we have 16 different curricula in Germany. But for the most part, there is no artificial intelligence part in the curriculum so far. So there are plans to introduce it into the higher educations, as far as we can tell. So in the higher K-12 classes, so which is actually K-13 in the state where I live. But so we're planning on integrating, or there are plans on integrating AI into that. But for now, most of it is voluntarily done by teachers who are interested in AI. And the second question was about the tool we used in the example I showed you, Snap. And that's one of the points is I think that when we need to, or when we think about platforms or tools for AI education, we should focus on platforms that we already use. And Snap is a great example for that. So Snap is very similar to Scratch, if you don't know it, and it's a block-based language that is used throughout education in Germany. So we have those text-based Java stuff as well, but we have now a lot of teachers using Snap, and we want to make the transition easy for people using those tools like Snap and Scratch to also integrate the AI education while allowing to use or show the underlying principles in the programming tools they already use, and not use new artificial tools which are cool to explain stuff, but which do not allow to implement your own AI algorithms like the teachable machine or stuff like that.
Thank you for your answer. Any other questions or comments? So the presenters, you can also ask questions if you have. I have a question to Mr. Stephen. So you have mentioned about Unplug. It is translated into Korean. Even elementary school students are learning it. So these unplugged applications are being used for elementary school students, but And also, they can use robots to learn about machine learning. So if we are to teach the basics of AI to the young children, is it meaningful to use unplugged, or is it more meaningful to use robots? So if there are some schools using unplugged, well, what is the main purpose of focusing on unplugged?
So I think the focus of Unplugged is to like illustrate the core principle and to leave all the stuff around that can distract you out of business. But I think there's also research showing that it doesn't matter if you start Unplugged first and then move to programming, or if you just start using a tool like those robots you mentioned. It just depends on how the teacher that integrates AI into education, into his curriculum, is like coping with the stuff. And if he's more willing to do Unplugged, that's totally fine because he's the guy teaching Unplugged. And if he's more into robots, I think he'll do robots just fine as well. So it always depends on your personal style of teaching. And if you like to illustrate those core principles with Unplugged activities, you're totally fine to do that. And if you like to do it with robots, you're also totally fine to do that.
Thank you for your great answer. Teaching students about the core idea of AI is the key. And I understand that basically the concept of data and the principle of AI learning, those will be the key of the course. You have to learn that first to apply into various other fields. Professor Lee, I have a question to you. Well, you're teaching students at school, and you have used educational platforms. So when you have done that for elementary school students, do you think that they get along with it? Do you think that the difficulty level is satisfactory? Maybe it can differ for online and offline education. What do you think? Well, for software education and AI education, you have to have the machine sitting in front of you. And there are many fun factors like game factors that make students to be more interested. I have been teaching software for about 16 years to children, but when we first introduced AI education, children show more feedback because it's more related to their everyday life. For example, software programming, well, the outcome is not directly applied to your everyday life. But if you have AI speaker at home, if you learn about the principle of how it is operated, and if you understand how the face recognition in your smartphone works with this AI education, well, it's directly related to your everyday life. So students find it very interesting. And whether they understand it well or have difficulties in understanding, well, it's like opening up the black box. So when you open up the black box, you cannot understand everything, but at least you know basic things of how things work and what kind of data is needed to make it work. That is something that even elementary school students can learn and understand. So when we taught students how to operate the machine learning and ask them, how can you apply this to create something that can be useful? They said that they want to create some apps to understand the sign language. And we asked them, how would that be possible? And they said that we can teach the AI some basic sign languages and it will learn how to interpret the language. It's amazing to hear that. And in some sense, AI might sound very difficult. And many people do not understand the principle or the theory of AI. But it was quite interesting to hear that young students can understand it and follow it and approach it easily.
So I feel that we need to make a good use of the platform and expand the use of the platform for education. Then, if we make an AI education platform, what are your expectations from your perspective?
Well, there are two, actually. Students should be interested in trying it, some kind of platform that makes students feel interested and makes them find it fun. So they should first find it fun, and we should make them dig further, like Google's Quick Draw. It is like a fun game following the drawing, but eventually they find it amazing how this machine is repeating what they are doing. So they open up the data set and then they can learn about it, and later they want to train the data set. So experience leading to the learning and application is something that we need for schools. So if it's just simple application or simple experience, well, that is not sufficient. So it should be encompassing everything from experiencing to actually applying it.
Professor Kim, are you still with us? Yes. I want to ask a question to Professor Kim. In Korea, if we develop an AI education platform that had better be connected to the curriculum of K-12 regular curriculum, so could you make any suggestions or proposals? As you know, in Korea, we have national educational curriculum which applies to all students. In 2022, if we officially adopt AI as a curriculum in the regular national curriculum, then we expect that the AI education will be conducted in connection with the regular software education. Then what will be the procedures for teachers to teach students about AI, and what kind of tools do we need to use to deliver more in-depth, profound knowledge of AI to our students? And the education must also include actual practice and experience-based programs. I think the AI platform developers, education platform developers need to consider this. And we need to be careful not to use the industrial AI platform data, but we need a separate data set tailored to the educational AI platform. Because if our purpose is to teach students, we need a different set of data. Sometimes, if we collect biased data, that will not really work well for the purpose of education. So I think we need to secure a good quality data set for the purpose of education. And we also need to collect real-life data and use it for developing educational AI platform. So I hope that we could have such an AI educational platform. One more question. Now, there have been changes in the education at universities. Regardless of the major, many courses are now being converged with AI and digital skills. And basically, in order to apply AI, what is the most basic concept? Data and algorithm. So data and algorithm are very important concepts. If students do not really know about data and algorithm, and if they learn about AI education at college, then they will find it very difficult to understand what the professor is saying. So in many cases, we see that college students learn programming, although they took the classes for AI. So if we prepare the AI education in the curriculum for K-12, then what will be the direction? What will be the desirable direction for developing the AI curriculum for the K-12? As you know, we have subject-named information. In the subject-named information, we teach students programming. We foster their basic programming competencies. And we hope that through the curriculum, students will be able to create an AI solution. And AI is one of the subjects reflected in the high school curriculum. So we hope that inside the national regular curriculum, we need to develop a curriculum that could actually help students continue their learning about AI from K-12 through to the college education. AI is not a totally new education, but we need to find a relevance between the AI education and the existing software and information education. And we need to establish a systematic curriculum so that we can effectively teach students AI.
Thank you. So we had presenters from Microsoft and Amazon talking about your platforms, and I understand that you have good computational thinking education in those platforms. And do you have a good curriculum for computational thinking and critical thinking for elementary school students as well? Well, we don't call it as a curriculum actually. It's not an AI course, but it's like a future-ready skill. And in the basis, of course, we start with digital literacy and computational thinking and its definition and how to implement it. Those are the prerequisite courses. Thank you for the answer. So Mr. Lee mentioned that AI, there are many examples of AI in our everyday life, and it's a good source or good tool to make students very intrigued. What is very important for students is to feel interested and to feel curious. They want to find out how things work. So making students feel curious would be your biggest task as a teacher. And these days, we have AI applied in every field, and that is making students feel curious about those things. Well, we say that children give up on math easily. So we find many students who feel fearsome about math. But if they feel curious about certain problems, then we can see them more persistently trying to solve the problem. So with AI and software, it can sound like something very specialized and difficult to learn, but we shouldn't do that. We should make students feel interested and curious, and it can be used as a good educational tool to help students learn even very difficult subjects. And if we develop this properly, well, it will not just end with AI education, but extend to other subjects like software education, language, science, math, and sociology and history, and etc. We can converge those subjects with AI to make students feel more curious about learning those subjects. Thank you for sharing your time despite your busy schedule, and thank you for your valuable comments. Professor Stefan and Professor Kim Soo-hwan, thank you for joining us online.
Thank you for having us.
예, 감사합니다.
So here we can conclude our session on AI education platform. Thank you for joining us. Thank you. So we had session 1 about AI education platform led by Professors Ha Jung-yeon. We had such a great, insightful presentations and comments. We could hear how universities and schools and the industry is focusing on creating good platforms for AI education, and we could hear about the cases in Germany. So this is the end of session 1. We will go on to session 2 after having a short break. So we will start session 2 at 5:15.
네, 여러분 휴식 잘 취하고 오셨습니까?
Did you enjoy the break? 2020 Global Software Education Conference. We have the topic of AI education. Thank you all for joining us, and we will now go into the session 2. Actually, this is the last session for the entire conference. So for this session, we will be talking about AI curriculum and policies and achievements so far. Let me introduce our moderator. We have the previous chairman of Korea's Software Association, Professor Kim Hyun-chul is here with us. Good afternoon. I am the moderator for our last session titled AI Curriculum and Policy and Achievements so far. AI education, in particular for K-12, has been receiving a lot of interest, and many countries are preparing for this. Today we had India. We have presenters from India and the US and Korea to talk about valuable information that you all must be very interested. So I will take my seat to prepare for the session. So I'm very much interested to hear how the presenters will introduce their cases. So Professor Kim Hyun-chul will proceed. So for the first presentation, he's well known in Korea, Professor of Carnegie Mellon University, David Turetsky. He is setting guidelines for K-12 AI education. So this is called AI for K-12. He is leading this AI for K-12 initiative. So, Professor, can you start?
Thank you very much for the invitation to speak to you. Can everyone hear me? Hello? Can people hear me?
Yes, we can hear you. You can proceed.
Okay, thank you. So I'm going to talk to you today about the AI for K-12 initiative and our work developing national guidelines for teaching AI in K-12. You might ask, why should children be learning about AI at all? And as we know, AI is powering the next industrial revolution. There are going to be huge economic and social changes brought about by AI technology, and we need informed citizens who will be able to deal with these changes. The second reason is that children today are growing up surrounded by AI, things like intelligent assistants, self-driving cars. So we don't want them to regard AI as magic. It's important that they understand how the technology works. And the third reason is that there will be many AI-enabled careers. And so we want children to begin thinking at an early age about how they might find a career related to AI. The AI for K-12 initiative was created as a joint project of AAAI, the Association for the Advancement of Artificial Intelligence, and CSTA, the Computer Science Teachers Association. We have funding from the National Science Foundation and from Carnegie Mellon University. We have a threefold mission. Our first mission is to develop national guidelines for teaching AI in K-12. And these are modeled after the computing education standards that were produced by the Computer Science Teachers Association. So their standards consider 4 grade bands, K to 2, 3 to 5, 6 to 8, and 9 to 12. We're doing the same thing. We want to define what students should know about AI and what they should be able to do with it. So that's the first component of our mission. The second is to develop a curated resource directory for K-12 teachers so that they can find materials on AI that are appropriate for young children. This includes things like online demos, software, videos, curriculum materials, activity descriptions, anything related to AI, but restricted to things that are suitable to the K-12 grade band. So there's a lot of university level material on AI, but most of that material is not accessible to K-12 students. And our third mission component is to foster a community of developers of new resources for teaching AI in K-12. So it's a mixture of people who are doing AI education, AI research, and people who want to develop software resources and curriculum resources for teaching AI. We have a steering committee. I'm the chair. The co-chair is Christina Gardner-McCune from the University of Florida. Fred Martin from the University of Massachusetts Lowell is now an emeritus member, and he's former chairman of the board of directors of the Computer Science Teachers Association. And Deborah Seahorn formerly was the co-chair of the CSTA Standards Committee that produced the CSTA computing standards that are now widely adopted in the US for K-12 computing education. In working on these guidelines for teaching AI, we formed a working group with K-12 teachers who are all experienced teachers in specific grade bands. So we have working groups for grades K-2, 3 to 5, 6 to 8, and 9 to 12. And these teachers are either in the classroom now teaching in these grade bands, or they have many years of experience and are now moving on to other kinds of work, such as training other teachers or doing curriculum development. So we worked with these teachers for 2 years to develop these guidelines that I'm going to describe to you. One of the first things we did was put together a list of 5 big ideas in AI. And you can see the graphic here that describes the big ideas. These act as the organizing framework for the guidelines. And this was inspired by the computing guidelines, which have a list of 5 big ideas in computing. So we wanted to follow the same model. And I'm just going to briefly go through with you what the 5 big ideas in AI are. The first idea is perception, that computers perceive the world using sensors. And you see in the figure here how a self-driving car might look at the world. It's detecting humans, it's detecting vehicles, traffic signs, and so on. The second big idea is that agents maintain representations of the world and use them for reasoning. So this covers representation and reasoning is a combination of algorithms and data structures, would be the computer science terminology. The illustration here is from a famous Go competition between DeepMind's AlphaGo and Lee Sedol, the famous Korean Go champion. Big idea number 3, learning, is that computers can learn from data. Some people think that machine learning and artificial intelligence are the same thing. That's not true. Machine learning is an important part of artificial intelligence, but there are other topics besides machine learning that make up artificial intelligence. Big idea 4, natural interaction, says that intelligent agents require many kinds of knowledge to interact naturally with humans. Now, this is a broad category. It includes things like natural language understanding, common sense reasoning, affective computing, which has to do with reasoning about the emotional states of people and responding to their emotional states. And it even gets at some topics like the nature of consciousness and the philosophy of mind. Big idea number 5 is also very broad. It says that artificial intelligence can impact society in both positive and negative ways. And it's important, we feel it's important for students to understand that there can be negative impacts of AI, and that in the design of AI systems, people need to take into consideration not just who will be helped by these systems, but who might be harmed by them. So there are 3 divisions of the societal impact big idea. One of them is the ethics of AI making decisions about people. So it's very important when we allow a machine to make decisions about people, such as who gets a loan, who gets admitted to college, who gets a credit card, It's important that those decisions be fair and unbiased. And it's important that the decision-making system be transparent so that people can understand why the machine reached the conclusion that it did. So there are ethical issues involved in making decisions about people, and there's some hard technical problems involved in making sure that machines are fair and understandable. The second aspect of societal impact is the economic impacts of AI. So we know that AI can lead to increased productivity, new types of services, new career opportunities, but we also know that some people will lose their jobs because of AI. So for example, self-driving cars are a wonderful thing if someone is disabled or too old to drive, but they're not so good if someone makes their living driving a taxi, say, and might be put out of work. So it's important to consider both the positive and the negative impacts when we look at how AI will affect the economy. And then the third aspect of societal impact is AI and culture. So young children now are growing up living with intelligent assistants, things like Siri and Alexa. And in the not too distant future, they'll be living with robot companions. Adults will be working alongside robots and intelligent agents. And this becomes part of the culture. And so it raises new kinds of cultural questions. For example, if you have a self-driving car, at what age is it appropriate to allow a child to travel in a self-driving car unaccompanied? There's actually a whole new genre of YouTube videos of self-driving car mishaps, or people falling asleep in their self-driving car, which is not completely self-driving, so they're not supposed to be sleeping, and yet that does happen. There are people who are daring the self-driving car. They'll step out in front of a self-driving car to see if it stops or not. So none of this stuff was conceivable 10 years ago, and now it's becoming part of the culture, and it's going to affect our culture and our society. So having defined these 5 big ideas, we put together a poster to explain these big ideas. This is intended to go up in the classroom, but we've also used this to help educate adults about artificial intelligence. The poster is available for free at aifork12.org. And these ideas really took off. They've been widely adopted now, and people have translated the poster into several other languages, including Korean, as you can see here. So the 5 big ideas were just the beginning of these guidelines that we need to define. The next step is to actually draft the guidelines, and this is what that process looks like. So we started out with a concept list. So for each of the 5 big ideas, what are the important concepts? And then we had these working groups, 4 working groups for the 4 grade bands. And these were partnerships between the K-12 teachers and some AI experts who were also part of the working group. And these working groups developed concept treatments that were appropriate to their grade band. So for a given concept, what could a student understand about this, say, in K2 or in 3.5 or in 6.8 or in 9.12? We had to take these concept treatments then and put them together into a unified whole. So we put them into a spreadsheet, and then the grade bands and the steering committee worked to try and reconcile these concepts so that they were consistent across rows and across columns. But that wasn't quite getting us where we needed to go. So the next step was to develop a synthesis to have a more coherent progression. And this was done, excuse me, by the steering committee with input from the grade bands. Finally, a draft version of the guidelines for each big idea will be released to the public, and based on comments received, we make revisions. So we've already done this for Big Idea 1. Big Idea 1 deals with perception. We released a draft grade band progression chart back in May. So you can see on this chart, the column headings are the grade bands, K to 2, 3 to 5, 6 to 8, and 9, 12. And the rows are various concepts. And so every cell is explaining how that concept would be covered in a particular grade band. So if we zoom in on this a little bit, you can see the beginning of the chart. We state the big idea. Big idea number one is perception. The idea is that computers perceive the world using sensors. So that's the one sentence statement of the idea. And then we have these orange boxes where we're trying to get at the most essential concepts that we want the teacher to convey to the students. So for perception, one of them is the idea that perception is the extraction of meaning from sensory information using knowledge. So perception and sensing are not the same thing. Perception is extracting the meaning from the sensory signal. And then the second big insight about perception is that there's a transformation from signal to meaning that takes place in stages with increasingly abstract features and higher level knowledge applied at each stage. And this applies both to speech understanding and to computer vision. So after these orange boxes, we have the concept list. The three major concepts for perception are sensing, processing, and domain knowledge. Each of those is divided into sub-concepts, as you can see here. And then for each one of these sub-concepts, we give a treatment in each of the 4 grade bands. So just to give an example, the very first sub-concept is sensing in living things. And in K2, we ask students to identify human senses and sensory organs. So the LO, that's the learning objective, what students should be able to do. And the EU is the enduring understanding, what students should know. So in K2, the EU is just that people experience the world through their 5 senses, sight, hearing, touch, taste, and smell. When we get to 3.5, we're asking them to do a little more. We're asking them to compare human perception to animal perception. And the EU is that some animals experience the world differently than people do. Bats and dolphins use sonar, bees can see in the ultraviolet, rats don't have color vision, and so on. So this is just a quick taste of what these cells look like in the grade band progression chart. Big idea 3 is learning, the idea that computers can learn from data. And what you see here are the 4 orange boxes for big idea 3, the things that we want the teachers to get across to the students. And some of these may only be appropriate for the upper level grade bands. But the idea is that machine learning allows a computer to acquire behaviors without explicitly programming those behaviors. That's the common definition of machine learning. But what we want people to understand is that what the learning algorithm is doing is changing the internal representations of a reasoning model. So you have a neural network or a decision tree that's doing some kind of reasoning, maybe classification, maybe prediction. And what the learning algorithm is doing is modifying the reasoner. So when a reasoner is capable of a large variety of behaviors, that's when a large amount of training data is required to narrow down the learning algorithm's choices about what behavior we're trying to achieve. And there is this separation between the learning algorithm and the reasoning algorithm. So once the reasoner has been trained by the learning algorithm, then the reasoning algorithm can be applied to solve new problems, and the learning algorithm is no longer necessary. So here's the concept list for Big Idea 3. The major concepts are the nature of learning, neural networks, which we treat specially because they're such an important part of machine learning today, and then a consideration of data sets. So what's next for AI for K-12? Well, we are going to be releasing the Big Idea 3 progression chart for public comment very soon. The slide says October 2020, but that date has slipped a little bit. So it'll be in very early November. Then we'll be revising Big Idea number 1. We've received public feedback on that. There is a plan to produce progression charts for Big Ideas 4 and 5 in early 2021, and then finally Big Idea 2. And in February 2021, there will be the Educational Advances in Artificial Intelligence Conference with a new special track on demos, software tools, and activities for teaching AI in K-12. So I invite you to join us in developing the guidelines or help grow the community of resource developers. Please visit us at our website, aifork12.org. And we do have a mailing list, and you're welcome to join the mailing list. The link is on the slide here, but you can also find the link if you just go to the aifork12.org website. So thank you very much, and I look forward to the panel discussion.
Thank you, Professor Tureski. So I am in your mailing list already. I know that it's midnight in your country. Thank you for joining us at this hour. So let's meet you later for the discussion session. We now have the second presenter for the second session. From India, we have a presenter. So he is from My Government and Digital India Corporation. CEO Abhishek Singh will make the presentation. The topic is about innovation and collaboration. So we will hear from CEO Abhishek Singh.
A very good afternoon to everyone, depending on wherever you are. A good morning. I am here. I'm my honor and privilege to be here talking to you on this very important summit. I'll be making a presentation on innovations and collaborations which can transform governance, and briefly share the insights that we have had in India by using technology for solving common governance challenges. So I'll be just sharing my slides and going through the presentation. Yeah. So innovations and collaborations transforming governance. So like the context is very common. This is something the whole world is facing. We all are, whether it's India or whether the United States or whether what began in China, Europe, everyone, we all are presently facing a common problem, a raging pandemic, and which is not subsiding. We have had cases across the world, deaths across the world, and scientists across the world are collaborating and working hard to build a vaccine that can help mitigate this crisis. In this context, when we have faced with such a challenge, I would like to mention about like how do we handle such challenges which are very big, which are very complex, which impact people from across the world, across the ecosystem. What we observed and what we have found was that whether it's this pandemic or whether the other crises that we have faced, that every such challenge requires innovation, it requires collaboration, it requires working with multiple stakeholders from across the world, especially in this pandemic. And every country was facing this problem and is facing the problem. How do we work together? How do we collaborate? How do we share knowledge? How do we share information? And how do we work with stakeholders across the ecosystem, whether they're from the government, whether they're from academia, whether they're from industry, and ensure that we are able to together solve problems. The challenge becomes like in order to face such challenges, how do we co-create knowledge and expertise from across the world? There might be some solutions which have been tried in maybe Korea, which can have applications in India, or whatever we have done in India may have applications in Africa. So this kind of knowledge sharing becomes a very important part of in our effort to tackle such complex challenges. The way we have been doing, the way we have done in India for across various problems that we have faced, and many other countries have also done it, is that we need to build agile teams which include members from government, from industry, from academia, and together they can come through quickly and work together. Because every segment, whether it's somebody from industry or somebody from academia or from the government, they bring in different kind of skill sets which helps in solving problems of scale. And together we are able to build solutions which are innovative, which are robust, and which are scalable, and which will help us to solve the crises that the world is facing today. So when we come to this approach, and when we come to COVID-19 especially, what we found was that initially when the let me go back to my previous slide, I think. when we're dealing with the COVID-19 pandemic, we found that this virus had a typical, very peculiar nature. And it was people who would get infected with this virus will remain asymptomatic for almost 2 weeks. And during this period, there will be a danger of this virus spreading and infecting other people. And since people who have been infected with the virus, they remain asymptomatic. They would not even know that they are unknowingly infecting others. So this made world over, whether it was Singapore, whether it was other countries, India, we found that it's very important to find who are the infected people, who are the people who are likely to be infected, and how do we find them at an early date. And this meant that contact tracing is required. So some contact tracing is done manually, but then technology today allows to do contact tracing at scale in a very robust manner. So in India, we decided to build up a contact tracing app, and that's how the Arogya Setu app, which is the world's largest contact tracing app, was built in India. So, and then the time required to do that was also very limited. In the month of April, when we started having more cases in India, it was decided to bring together a team of people. In fact, 2nd April it was launched. So March, the work started, and over a period of 3 weeks, a diverse group of stakeholders, professionals from academia, from industry and government, they got together and they started working on a Bluetooth contact tracing app, which could also track location of users, which would help people to get to know whether somebody who has been detected COVID-19 positive has come in contact with anyone else in the preceding 2 weeks, and that would give an alert to anyone who has come in contact with somebody who is COVID positive, a warning well in advance that would help them handle, that would help them take care, take precautions, and ensure that they don't further infect others, and they stay home, and the spread of the virus is prevented. So this was built in a record 15 days, and within 13 days it got to 50 million users, and over the last 7 months now we have got 163 million users who are using across India. And what we found was that the efficacy of the app was found in the Bluetooth contact, which the app traces. They are able to, the testing efficacy, like those who are identified as Bluetooth contacts of people who tested positive, when we test them, those who have been advised testing, we get testing rates of almost 45% against the overall population testing positive rate of 8%. So this ensures that testing infrastructure can be more optimally utilized. It can be the testing equipment, healthcare professionals can be more optimally utilized, and the testing efficiency goes up. The app also captured location data, which is used at the aggregate level for mapping emerging hotspots and containing the virus. And what it has done is that it calculates COVID hours based on the location data of people who have been traveling. Location data of people who have been traveling at various locations before they are identified as COVID positive. And this location data helps in identifying emerging hotspots. And in areas where this data has been used, it has helped to predict hotspots 10 to 12 days before that area is actually detected as a COVID positive. And locations where this was done effectively, they have been saved, in the sense that these locations, people were contained, restricted movement restrictions were there, and those areas turned out to be safer than other areas where this was not used. The technology played a key role, but the more important thing was that we have observed in this implementation was that the nature of collaboration, of how we build trust between government, between industry and academia, everyone coming together, building an agile team, and being able to implement the project in a very rapid time frame. So what has also been observed was that another aspect that we found, especially in COVID-19 communications, was that till we get a mask, the only thing that is going to protect us, that's going to ensure that we stay safe, is behavioral change. use of masks, hand washing, social distancing. So these are the communication measures that was required for containing the virus and its impact in a country of our size and magnitude. So right and effective communications became a very important approach in our entire fight against the COVID-19. And MyGov, the citizen engagement platform of Government of India, it launched the COVID-19 communications to support the health ministry. When we began the campaign in the month of February, we realized that there are words that were not part of the lexicon, whether it's quarantine, whether it's social distancing, lockdown. People didn't know what it meant. But now they have become very common terms, but it required communicating effectively, communicating better. Then another aspect that was required in the initial few months was how do we bust myths? How do we fight fake news? How do we simplify government directions? Because there were multiple directions that were issued with regard to what is allowed during a lockdown period, what is not allowed. So people are not very clear about official documents, which were very often written in the legal language. So MyGov created infographics and helped people understand what we are doing. Then we used videos, we used podcasts, we used community radios, and we use all social media platforms for allowing people to get to know more about the virus, more about the do's and don'ts, more about the precautions that they should take, more about how we should build up the immunity, learn to know what doctors are saying, learn to know what experts are saying, and be better informed. We used all the social media platforms. We built the AI chatbot on WhatsApp, which allowed people to ask questions and get real-time answers. That helped in effective containment of the virus. We built a Telegram news channel, Telegram channel on COVID-19, and that channel has become one of the largest channels on Telegram in India with almost 3 million followers. Similarly, we use the Facebook, Instagram, Twitter, LinkedIn, Roposo is a short video platform, YouTube, ShareChat. So all these platforms were used to communicate effectively with regard to the COVID-19. Then the challenge that comes is that while innovations are nice, innovations are good, the challenge becomes like, how do you sustain innovations? So whether it's for COVID-19, whether it's for Arogya Setu app, we need to ensure that whatever innovations are done are sustainable. And it should not be for headline management, that something has been done and we have achieved these results and we kind of advertise it, claim credit. That should not be the objective. It should be done in such a sense that even after the champion who is driving the innovation goes, the innovation remains. It requires effort, it requires consultations, it requires brainstorming, it requires the actual ground level staff evaluating options and then deciding. Another example that I would give about a project which I was associated with in the Food Corporation of India, which does massive food grain procurements of more than $40 billion in a year. The depot online, it works through a network of godowns which store food grains. It buys food grains from farmers, it procures it, it stores it, and it transfers it to all over the country for distribution under the public distribution system. So all this system was manual, and we decided to make it online, make it electronic. But when we're doing that, we realized that the processes that were followed in manual mode across different depots and across different parts of the country were different. But when you're going digital, you need to standardize the processes. So how do we do that? So we decided to have brainstorming sessions with the actual stakeholders, and more than 45,000 of them who will be actually required to implement the project at the grassroots. So we used technology tools. We broke silos. We kind of created a flat platform using Facebook groups and using WhatsApp groups in which everybody could give their suggestions, right from the last person in the depot to the top management. And that helped in effective communications and sharing of ideas. And sometimes the best of the innovations came from people who were down below, who were actually implementing the projects. So that really helps in a direct connect with the stakeholders, really helps in building solutions which can be scaled up, which can be used, which can be implemented faster and better. So the common service centers, that the telecenters project that India implemented, and now we have a network of more than 400,000 such telecenters across the country who are offering digital services, breaking the digital divide, making people access services at the last mile. That was also like when it was implemented in 2010, there were a lot of naysayers at that time because the number of e-services was limited. But over a period of time, these centers have become more sustainable, And the model that was pushed at that point of time was a service procurement model on a public-private partnership mode. And this is also like sustained because as SPV was built up, it was given a kind of a corporate kind of structure, and the village level entrepreneurs who were running it across the length and breadth of India were made real stakeholders for ensuring that the innovation was actually sustained. So the question comes to that is that how do we nurture innovations and how do we nurture networks for ensuring that innovations don't die with the champion who is moving that? We need to take a few steps, and some of that I would like to share today. Is that what is needed is that we document the best practices, we share across. We don't need to reinvent the wheel. Find out what has been done. Some Brazil has done something very good in healthcare, or some other country has done something good in providing last mile service delivery, or something good to improve the broadband connectivity at the last mile. So those examples which are within our country, across anywhere else, if we are able to find out and learn about it and use it. And similarly, whatever we are doing, very important, document them so that it's shared with others and more people use it. So that helps in ensuring that the more people use, the more the innovation will be sustained and retained. Then the teams have to be credited behind. It's not, whenever we talk of an innovation, it's not only the leader. We have to ensure that a whole team that is working on that is promoted. The unsung heroes are given the due credit, and the leader only provides the direction and support. That's very important for any such innovation to be sustained. Then what I always call it is that a network of civil servants, especially there are a lot of people who want to do good, who want to find partners who can help them do good, learn about good practices. So what I call it as a nexus of the good that helps in building a network, that helps in learning from each other, ensuring that innovations remain and are strengthened further. Building partnerships is very important with the civil society, with non-profits, with multilateral agencies, learning from each other, learning from different countries, learning from good examples like this forum that is there. I'm sure there will be many examples, many case studies here of people who have done great work in their own countries. If we can learn from them and we can adopt, we can customize and adapt it in our own workplaces, in whichever forms required, it will really help in building sustainable innovations. Alum groups have been very effective, whether it's my engineering college alum group or public policy Harvard alum group. It gives you a lot of advice, unbiased advice that you get, and it's very useful to connect with them, get to know what are the best practices and what is it that one needs to do better. So that really helps in sustaining innovations. Then there are innovation circles around the world, whether it's the World Bank or with the United Nations, multiple bodies, multiple circles, innovation circles. There are people who are trying to solve the same problems. Like when we are looking at the vaccine for the COVID-19, there are several initiatives that were going on across the world. How do we learn from each other? How do we get into them? How do we build a network so that which helps us in learning? How do we collaborate with people across? That really helps in improving things and designing solutions that can solve societal problems. And we find that very often it's not that different countries face different problems. Most nations are facing the same problem. Can we not just do Control C, Control V and ensure that we are able to quickly move faster, better, and ensure a better outcome for our citizens and our people? So that's very critical in any approach that we do. Learn, practice, implement is something that I follow personally, and I ensure that my team follows. Document and share in order to ensure that whatever we are doing is documented well. People get to learn, people get to adapt, and sharing so that the multiplier effect comes in and more people adapt it. So these were the few thoughts that I had that I wanted to share with it, and more of it I would love to look forward in the question and answer sessions. Once again, thank you for giving me this opportunity to be talking to you on this platform, and hope to learn from the other presentations in the time to come. Thank you.
Thank you very much. So in resolving the problems we're faced with due to COVID-19, AI and other technologies will play a very important role. In India, and schools in India have been making a lot of efforts, and we'd like to listen to more about this during discussion session. I'd like to invite the third speaker. I'd like to invite Dr. Song Jong-suk from Korea Foundation for the Advancement of Science and Creativity. She will make presentation on national curriculum of AI in Korea. Professor Turasky talked about the curriculum in the US. Currently in Korea, we are creating national curriculum for AI. Dr. Song Jong-suk has been participating in the process of making national curriculum for AI in Korea. Good afternoon, ladies and gentlemen. I am Song Jong-suk from Korea Foundation for the Advancement of Science and Creativity. I'd like to make presentation about the fundamentals of AI, which was reflected in Korean national curriculum in September. We have developed the AI Fundamentals course, which was announced for the first time in Korea in September, which was adopted in the national curriculum. So I'd like to introduce to you about the content of our national AI curriculum, and I will explain about other subjects that are related to the AI. So you may not be familiar with the system of national curriculum in Korea. In Korea, when we feel that we need to teach students a certain subject that does not exist, we actually ask the Office of Education for their approval on the creation of such a curriculum. So our foundation created several subjects to be reflected in the national curriculum, so I'm going to explain about them as well. First of all, I'd like to explain about information education, which serves as the foundation for AI education. We call this information subject as computer education or software information. I am saying information education because the title of the subject is information at schools. In Korea, computer education related subject is called information, which is different for each school level. For elementary schools, we provide software education under the subject name practical course, which is for 5th to 6th graders. So officially, the software education starts from the 5th to 6th grades. They focus on experiencing how software works. And at middle schools, the name of the subject is information. Information is an official subject. So all middle schools are supposed to have this information course, information subject. And the name of the subject for high school students is also information. This is not mandatory but elective course. So according to the data from the Office of Education, about 50% of high school students choose to take the information subject. And these days, many students demand education on information more. So later on, when we implement a new credit system at high schools, the more students will be willing to take information course. So this is the curriculum for high schools. There's a subject which is called Career Path Elective Course. So these are the subjects the general high school students learn. And there's a specialized course. For example, there are subjects related to computer, which is called information science, customized to the students at the science specializing high schools. And students also learn about computer-related subjects like computation, but such subjects are for students who would like to get a job after graduation from high schools. As mentioned before, information education is the basics of AI. So before taking the AI subjects at high schools, students first take the information course at middle school. So we need to figure out the level of middle school students. At middle school, the subjects are categorized into 4 areas. In the first domain, they learn about information culture. In the second category, they learn about data and information. The third domain is problem solving and programming. So we selected 3 core concepts for this. The first one is abstraction. Abstraction is to understand the problem and draw out the key factors. So abstraction is one of the key concepts, and the other concept is algorithm and programming, which actually put what algorithm represents into practice. The last domain for middle school's information course is computer system, which is related to controlling hardware. So middle school students learn about these courses, and then they come to high school to learn about the fundamentals of AI. AI fundamentals are related to information course. That is to explore the principles and technologies of AI based on the knowledge of information culture, computing thinking, and cooperative problem solving. There are 4 domains for the fundamentals of AI. Firstly, what is AI and what kind of future will be brought about by the AI? That's the first domain. In the second domain, we let students experience the characteristics of AI and learn the applications of AI. The third domain is one of the hottest domains. The third domain is about machine learning and data. So we teach students the attributes of data in the third domain, and in the fourth domain, students understand what AI is and how AI works. So in the fourth domain, they learn about what kind of advantages or disadvantages there are brought by the AI. They also learn about the ethical issues of AI in the fourth domain. So this is structured as a career elective course. So students, once graduated from middle school, can take the fundamentals of AI as a career elective course. And we are trying to refrain from using too difficult technical terminologies. And the goals of fundamentals of AI, the basic purpose is to help students foster their basic knowledge of AI, learn about ethics of AI, and increase the ability to use AI. Also, we're trying to foster students' creative problem-solving competencies. In the first domain of the fundamentals AI, we learn about intelligent agents. For example, in Korea, AlphaGo is very well known, which is an intelligent agent. So we interact with or meet with a lot of intelligent agents with AI algorithm embedded in itself. And in the second area, people often associate AI with machine learning, but AI includes not only learning, but also recognition, search, and reference. So recognition, search, and reference, and learning are the key concepts of AI, and there are many tools helping students experience what those core concepts are. And learning is one of the hottest topics which is related to machine learning. So I'm going to briefly explain about the curriculum related to machine learning. The third domain includes data and machine learning. As mentioned before, there are so many things to deal with under the third domain, but here we deal with machine learning model, and there's a project for students to participate in to actually implement the machine learning model. And we think that the classification model is one of the most proper models to be taught at high schools. And lastly, the fourth domain is about social impact of AI. In the three domains previously, students learn and experience how AI works. And in the fourth domain, students learn the positive influence and negative influence of AI, and they also discuss the impact of AI on the society. So far I explained to you about the official AI-related or information-related courses. And there are other types of subjects that are not officially included in the regular curriculum, but are approved and recognized by the education authorities to be taught to the students. So our foundation is developing various curriculums to be included in the curriculum for schools. So this is a list of subjects that we developed as textbooks and subjects to be taught to the high school students after the approval from the government. So for two of those subjects, we have already received official recognition from the Ministry of Education. And after approval on our application for developing these lists of curriculums and textbooks, we start developing the detailed content. And we expect that many schools will be using the curriculums and courses we developed. We also support teachers and provide trainings for teachers, and we also support schools to transform the obsolete computer rooms into innovative information labs. And in order to enhance the potential of teachers, we are carrying out projects to enhance the teachers' competency. So we will continue our efforts for further development of software and AI-related education in Korea.
Thank you for your presentation. So we could hear what are being prepared in Korea for K-12 AI education. So we had 3 presentations. Now we have 2 panelists to be invited to comment and ask questions to the 3 presenters. First, we have as our panelist, Professor of Sungkyunkwan University, Mr. Kim Jae-hyun from the Software Education Institute of Sungkyunkwan University. He is engaged in various AI-related educations. Second panelist is a teacher of Osang High School. So she is the president of the Korean Association of Informatics Teachers. So she will be sharing a lot of insights and opinions from the view of a teacher. First, each panelist will spend about 5 minutes to comment or ask questions to the 3 presenters. First, we have Mr. Kim Jae-hyun, Professor Kim Jae-hyun. You can start. Nice to meet you. I am professor of Sungkyunkwan University, the professor of computer engineering. I had listened to the 3 presentations. I would first thank all the presenters for the valuable presentation. It really helped me a lot. So AI and the 4th industrial revolution, we talk about them as factors that will be changing our lives, not just in industries, but also in various fields, including education. They will be affecting our lives, especially with the COVID-19 pandemic this year. We have a lot of remote education, online educations being provided. So we were thinking a lot about how we can utilize these technologies for education. There are different variations among different countries, but still we are all involved in an in-depth discussion about this. So we have a common issue to tackle. And we heard about the US case, AI for K-12 initiative. And in case of the US, I could see that it starts from K2 to K12. You have this big framework. You have 5 big ideas for that initiative. So I think we have a lot of similarities. We share a lot of your big ideas. In particular, the fact that it starts from K2 to K12, when you look at the contents of the education, what should be taught into how much depth, that is something we need to study further. In the US, I understand you don't need to worry about the teaching hours. You just focus on the contents to be delivered to students. So the teachers could have some flexibility on what they teach to students. But in case of Korea, the situation is a little bit different. The school curriculum is defined by the government, so we have to meet certain requirements like teaching time and etc. And we heard from researcher Sung Jung-suk about that big direction. What are the curriculums or courses provided to K-12 students for AI education in Korea? Well, those basics of AI courses, when we were creating them, well, these courses are targeting the middle school students who have completed the basic IT course already. And we had a difficult time deciding the difficulty level of this AI course, because for middle school students, they take about 34 hours of basic IT. But for high school students, it's not in the regular curriculum. So if it is in the regular curriculum for high school students, we would have more in-depth teaching for students, but it is just optional course. So that is why we have some concerns about how much concrete details we can deliver to students. So this course called AI Basics, actually, anyways, we have created this course with such a short time and started to provide it to students. But so I think that is at least quite meaningful. And there are 6 courses developed so far. And when we actually see how they are being taught at schools, well, there are like a total of 6 courses. And I understand that local educational government institutes and this COFAC have collaborated together to come up with the course curriculum. And I think we would need to work together further to make improvements. And they worked really hard so far to create those courses, but how they will be implemented in the field at schools is something else. And we also would need more efforts on that regard, how we can actually make use of those courses. And the AI Basics course, in our current regular curriculum, it is covering the understanding of AI and social impact of AI. So I think that is one of the big characteristics of Korea's AI basics course. So what kind of social changes will be made by AI is covered in that course. And we also teach the theories of AI, and data-based machine learning is also taught. So I think that is a differentiating point for the Korean curriculum on AI. And that is it for my comment.
Then we will take questions later on. We'd like to listen to Mrs. Seo first. I am Seo In-soon. I am the representative of Korean software education teachers community. As AI is going to be the regular curriculum, many teachers have interest in this, and many teachers are passionate about how they're going to teach students. Actually, we knew that we have to teach students AI, but we were confused about the way we have to teach the students, and we were confused about how we should teach students by using what. But fortunately, in Korea, AI is now announced to be the one of the regular national curriculum, but it was announced that AI will be the selective elective subject at high schools. And students who completed the previous information and AI information course at middle school can take the AI basics subject in high school. High school has two elective courses. One is general elective course and the other is career path elective course. As for general high school students, they first choose general elective courses, and then their second choice is career path elective courses. And the AI course at high schools can be taken by students as an elective course without learning the general elective course. So should students learn only information subjects at high school without taking AI course? Or which one do they have to take, and which one comes first between AI fundamentals subject and the information subject? So there's a little issue about the hierarchy of the curriculum courses. If we had established AI as a mandatory course, then the situation would have been better. That's what I am thinking. And if we establish the credit system for high schools, which allows more high school students to choose the subjects they want to take, then we can develop more in-depth AI-related subjects for high school students. In the case of China, they have a lot of information and technology-related courses. So I think in Korea, we need to provide more options of choice for students who would like to learn AI. And we need to also create AI subject in the middle school students' curriculum so that we can achieve better connection between AI study at middle school and AI study at high school. And the AI is actually the first subject that has been newly created and set as the official regular curriculum. To prepare for this, many teachers are receiving trainings and they are very passionate about teaching AI to students. But creating AI subject is not the goal itself. We need to help teachers provide better quality AI education to students. For this, we need to support teachers and we need to provide teachers with good resources that can be used for their classes. This will be all for my comments.
Thank you. So I think there should be a lot of questions directed to the presenters. I assume that you will be asking questions during the discussion time we have from now on. And researcher Song Jung-suk, you said that for the AI curriculum of Korea, it is just being created, and maybe from next year we can have it in the regular curriculum for K-12. So the government is taking the initiative to fully embrace it. And Professor Turetsky and Ms. CO Singh, you heard her presentation. So I want to ask both of you how you think about that plan of Korea. Any comments or advices for Korea?
Well, one comment that the last speaker made that I want to emphasize is the importance of supporting teachers. Even teachers who are experienced teaching computer science may never have been exposed to AI before. And so we have a lot of work to do to make teachers comfortable with the AI subject matter before they're able to teach it to their students. And I know that's a big problem in the United States, and I assume that it's the same way in Korea.
In fact, I would like to agree with what Professor David just said. In fact, that's the most important challenge that we are facing when we have to bring in AI in the curriculum, the school kids. How do we ensure that the teachers have the right resources, the grade-wise curriculum, like what do you teach in grade 6 and what do you teach in grade 7, and having the right infra at the schools, because in India, we also have the challenge of that not all public schools have a robust connectivity and computer infrastructures. How do you provide for computer labs? How do you provide necessary skill sets? How do you upgrade the skills of the teachers? And how do you kind of leverage AI also in many ways in order to ensure that students have the right teachers to learn AI from? So a lot of common resources are put up on our digital platforms through which the students can learn. So that's what is being done right now. But yes, the problem that we identified is very real and very relevant for not only Korea, but the world over.
Thank you very much for your important comments. So, anyone has comments, or would you like to add anything to what those two gentlemen mentioned? Thank you very much for your good opinions. We've been thinking about the same thing in our foundation. That's why we think it is very important to provide training for teachers. And in Korea, the law on elementary school and middle school education requires us to produce textbooks for whatever subject that is reflected in the national curriculum. And we will have to make efforts and provide support for producing good quality textbook for AI education. And next year, we will support 500 schools that provide leading AI education to students. And by supporting those 500 schools that provide AI education to students, we will get a lot of lessons learned from them and good case examples, which will be helpful for teachers.
I actually rather have a question to Professor David Turetsky. I have a question to you. Well, one of the biggest debate we had was, well, when we translate something from English to Korean, we have some issues. Like, for example, the term cognitive thinking, the term we use for that in Korean is a little bit depending on it can be discussed a lot, and coding as well. If we translate it into Korean, the coding can mean like programming in Korean. So there were a lot of debates about that, and people also called coding as software education. And we are talking about AI education here. So you have coding education in the US, and now we are here talking about AI education. Can we say they are different things? Actually, I studied in the US, and in the US, you have computer science as a course that has been taught at universities, and you have not changed the name of the course for such a long time. But in Korea, we are changing the names of those courses constantly. So what is the difference between AI education and software education? So do you think that we have to split AI education and software education as two different subjects, or should they be converged together?
I think that's a very interesting question. When I first started studying AI, which was some 40 years ago, AI was a mixture of computer science, but also cognitive science and psychology, even some interest in neuroscience. And I think today AI is seen as more thoroughly computer science. It's moved away from the early roots in trying to understand human thinking, but it hasn't completely lost contact with those other fields. So I don't think AI is the same as software engineering, because it does touch on these questions of what does it mean to understand language, say, or what does it mean to perceive the world? Even questions like consciousness, which are a little bit outside of the normal purview of AI, but they're the kind of things that AI tries to make contact with, and we don't see that in software engineering. I think in the K-12 level, you can teach AI without teaching coding. So there are lots of things to learn about how machines learn, about how they perceive the world, about how knowledge is represented, that can be done without writing code. And there are wonderful tools now for K-12 students that will let them do things like train a classifier using, say, Google's Teachable Machine, or using machine learning for kids, or there are now extensions to App Inventor. So kids can learn to build AI applications without doing any coding at all in the case of something like Teachable Machine, or with only minimal coding with things like App Inventor. So I do think there's this distinction between AI and coding, or AI and software engineering. I think they're different subjects, but of course they're both related to computer science.
Yeah, exactly. If I may just add to that, very often the beginnings of AI is data science. So very often, to understand data, to understand analytics, and then you kind of bring in the concepts of machine learning and AI. So coding comes much later. So essence of AI is to understand data, to understand how you work with it, and how do you build predictive modeling. So a lot of it is more of understanding this part of it, and then you use the coding to build AI-based models. So that is how very many courses and the curriculum is being designed in India, especially for the school kids.
Thank you for your comment. Dr. Abhishek Singh, I have a question to you. So in India, how do you provide the software education and AI education in India?
Yeah, we have, like, as part of the curriculum, we have at various levels the subjects which have been introduced right from grade 6. As per the new education policy that we have, in grade 6, children start studying coding, and they get about coding is basic programming languages, and then about data science and about AI. And in partnership with industry, what you've done is that in partnership with companies like Intel and IBM and Microsoft, we have designed an AI-based curriculum for school kids. And this curriculum is being taught with textbooks and trained teachers for students. And recently launched a program called Responsible AI for Youth, in which the level 1 course of AI for school kids was implemented all across the country. More than 50,000 kids took that level 1 course, and out of which 11,000 have completed it in just 6 weeks, and 100 of them are going ahead to build AI-based models. And I'm happy to say that all this is done in partnership with industry, and Intel has been one of the major partners for this course, the Responsible AI for Youth, and many of these students took part in a mammoth exercise on the 14th of this month, last month, and they created a Guinness Book of World Record for undertaking a AI-based lesson at a single point within a period of 24 hours. That was the maximum number of children who take an AI lesson. So what it helps is that these campaigns and these projects and these demos and these records also brings in awareness about AI and makes students interested in that. And then the resources which are available make them access these courses and learn about AI.
So he mentioned the issues related to teachers and how are we going to view the computer science courses and AI courses. Actually, we have teachers here. We'd like to listen from teachers about how we need to operate the new AI course and the existing information course at schools. Yes, I am a teacher. I'm teaching students. Actually, it was not that we suddenly came up with AI curriculum, but we were not fully prepared to teach students AI. In Korea, we received trainings to reinforce our expertise and competencies to teach students. Maybe if it doesn't necessarily have to be a training, but there could be some platforms or some mechanisms to help teachers enhance our skills in AI so that we can deliver better education for students.
So anyone from the three presenters willing to answer her question? Yes, I mentioned it briefly. Well, we have leading schools participating in AI education. So teachers participating in those leading schools will be sharing some best practices. So if we do that, that kind of knowledge sharing can be a more practical way of teaching other colleague teachers to learn about the teaching methodologies. And at the educational university, we are nurturing the AI teachers. I believe you know about this better than me. So I think that the kind of university curriculum can help us nurture the future AI teachers. Any other questions or comments? So Ms. Sung mentioned this. At the University of Education, there is the AI Converged course to nurture AI competency for teachers. This started this year. So in case of Sungkyunkwan University, we have our educational college, and we have MOU with 5 cities and districts of Korea to have about 5 semesters course to teach this. And actually, if we look at the teachers joining our curriculum, their background is very diverse. About 1/3 has the background of majoring in this engineering subject, and the others are the non-technical majors. So in terms of information, well, we can say that the course is the AI Converged course, but for non-technical majors, for them to use the teachable tools and etc. Actually, it is more like teaching them. Well, I think it's more practical to teach them how to use those existing platforms. So if that's the case, then of course, I believe that the teachers who majored in those engineering majors should be teaching it, but it might also be practical to have non-technical major teachers learn how to utilize those platforms and make it easier for students to access. So those are some debates to be carried out. So there could be some teachers who majored in how to teach students learn about engineering and etc. But in case of Sangkyungwan University, we are more focused on the methodology of the teaching. So I think that we need to classify the types of teachers, the ones who are more focused on the principles and the ones who are more focused on the practical use.
Thank you very much. I'd like to talk with Professor Turetsky. You are now working in the AI for 12K initiatives. Many Koreans are very much interested in that initiatives, and we are receiving a lot of help from that initiatives. Actually, it's almost the first time for us in Korea to teach AI to K-12 students. So your initiative is actually the only resources we can refer to. So we are referring to your resource a lot, and based on that, we are creating our own. And the US, India, and Korea and other countries may need to cooperate with each other. We need to establish an international cooperation system so that we can share researches, information, and experience. So, Professor Turetsky and Dr. Singh, what do you think of this idea? And then we will close the discussion session.
I agree completely. There's lots of opportunities, I think, for scholars at different countries to help each other. And we set up the Africa K-12 initiative to define guidelines for the U.S. simply because we didn't think that we should be telling other countries what to do because their education systems are different. But we're very eager to learn from what other countries are doing. And we have members on our advisory board from China, from the UK. We would be interested to find a Korean colleague to add to our advisory board as well. And thank you for your very kind remarks about the AI for K-12 initiative. But I should point out that there are other groups who are releasing AI curriculum materials that might be of use to you. So AI for All has their open learning platform, and ISTE, the International Society for Technology and Education, just released an online AI course that they developed in collaboration with IBM. MIT has developed an AI ethics course. This was done by Blakely Payne at MIT, and schools are making use of that. So we're seeing more and more resources become available, and we're also seeing interesting things from other countries. So some of these things I think will be described at the upcoming EAAI conference in February.
Thank you. Almost time's up, so I think we have to close discussion. Thank you for your attention. We have to close the session due to time constraint. Thank you. We have discussed the policies, curriculum, and achievements made in the area of AI education. We have closed the last session. Thank you very much, moderator, and the discussant and speakers for the session, for all your efforts. We have hosted the 2020 Global Software Education Conference online. It's time to wrap up the conference. We discussed AI technology, society, and we discussed how we rethink education in this new era. With many experts, we have successfully proceeded with the conference, and there have been active discussions and presentations. Thank you very much for your interest in this conference, and we hope that this conference will be able to propose better direction and strategies for the future of AI education. We hope we could meet with you in person next year with more enriched programs. Thank you very much.